morning all. I welcome you all for the Day 2 conference of 3rd International Conference on Emerging Trends in Engineering and Technology, organized by Department of Mechanical Engineering, Sandeep Institute of Engineering and Management, in association with Institute of Engineering Research and Publication. I would like to invite our keynote speaker, Professor Mohammed Fayad Sir, Full Professor, St. Joe's State University, CEO, VRL Software Engineer, San Francisco Bay Area, California, United States of America. Heartily welcome, sir. Dr. Mohammed Fayad Sir is a full professor of computer engineering at St. Joe's State University since 2002. Previously, he was J.D. Edwards Professor of Software Engineering in the Department of Computer Science and Engineering at the University of Nebraska-Lincoln from 1999 to 2002. Between 1995 and 1999, he was an Associate Professor of Computer Science and a Faculty of Computer Engineering at the University of Nevada. He has more than 15 years of industrial experience, in addition to 10 years as a software architect in companies such as McDonnell Douglas and Philips Research Laboratory. His reputation has grown by his achievements in the industry. He has been an IEE Distinguished Speaker, an Associate Editor, Editorial Advisor, a columnist for the communication of ACM. His column is Thinking Objectively, a columnist for Al Ahram Egyptian's newspaper, an editor-in-chief for IEE Computer Society, Press Computer Science and Engineering, Practice Press, since 1995 to 1997. A general chair of IEEN, or Arab Computer Society International Conference on Computer Systems and Application. Beirut, Lebanon, June 26 to 29, 2001, and the founder and president of Arab Computer Society from April 2004 to April 2007. Dr. Fayad Sir is a well-known and recognized authority in the domain of theory and the application of software engineering. Fayad Sir's publications are in the very core achievable journals and conference in the field of software engineering. Welcome, sir.
Thank you very much. I appreciate it. I would like to welcome everybody here, and I want to thank everybody coming to visit with me. The subject I would like to really explore with you is very new and is very innovative, and actually it has a very high impact on everything. So let me tell you what I do exactly in my life. I did a lot of abstraction and build a lot of systems. And I ended up finding out with the concept we use, we don't know it very well. So those concepts we speak and we utilize in our technology, and we do everything, we're not doing it a good job with it. In fact, I come to the point, all the knowledge we build is really not complete. We're actually talking about what really the service of the knowledge, not the knowledge itself. What this means every concept we deal with, it's actually very important for us to really understand. And actually this concept has, and that is covered, more than 50 innovative keys for every concept. And every innovative key I do an art of abstraction for it. And therefore, for example, I will mention those keys and I'll give you examples. And those examples, you will wonder, this is knowledge nobody knows. So the idea of really dealing with concept, the concept has a lot of property people doesn't know. That's why we're talking about a concept here, which is I could document it from 3 pages to really 10,000 pages, one single concept. What does this mean? Means this is again hidden data we don't know. That's why the art of abstraction here, every key we talk about a new concept, a new key in a concept, we discover those new knowledge about it. So we start this with a normal building software systems and modeling, and we do a lot of stuff. And all I discover, all what we're building based on tangibility. What this means, we'll build something we already see and really touch it and really know. And the funny thing also, we're building system of instance. For example, we have a concept called account. So we build an accounting system for banks and for financial institutions. We have the same concept in computing. We're building a computing accounts. We have the same concept with actually, if we've been judged or something like that, that's also an account. So the idea here, the missing thing there, which is actually important to build any system, is to understand what I call the functional, non-functional, as well the ultimate design for that specific. This is very important, three things. And actually I discovered non-function by itself has 13 innovative cases nobody knows about. And to really tell you every concept we use, it has also a rule of conduct, which is very important for us to know. Nobody knows. And is actually, this is very important there. So let me give you some ideas, So we use concept we don't really even understand, by the way, and actually we use it in the wrong context. So are you with me? Are you, do you have any questions? Please tell me if you have any question. You write in the chat, very good, and we'll look at this. So this is, again, I got the conference is live on YouTube. Very good, I like this. So in this case here, I take some simple concept and some really other concept and actually talk to you about certain innovative keys on those concepts. So for example, one of the rules in this new technology or new languages, and actually this would really ease the communication between everybody, because again, those concepts are really, we use it as human in everywhere. The concept project, this is very important. I would like to ask you a question, and you might really participate with me. Well, the concept project has a lot of different goals. And unfortunately, because of this, we're building the wrong project all the time. I discovered this concept has an ultimate goal. This is actually very important for us to know when we build any project. So coming back here, before I start really talking about concept, I have a new classification for concept within the natural language. So we have 3 different type of classification, because you need to know that. When we call them, the first category, we call them enduring concepts. By the way, I do have a lot of publication, and I would really love to share this publication and video with you. So I'm going to leave contact information here. I'm going to show you many access to my sites to look at all the videos. This is all videos. So the first group of concepts, we call them enduring concept. They're very high level concept. They actually continuous. They actually enduring, and they actually goal of themselves. It's like marriage, like love, like privacy, like inflation, because this is continuous. It is not really have a beginning and end. So, and this is actually goal for themselves, by themselves. Now, we have a second set of concepts, which is, we call them the things we do, work, activity we do. This is actually every concept has a beginning and end. And those concepts require an ultimate goal, just an ultimate goal. So, and I'm going to talk about this rules to explain with different key terms. Those concepts also is stable, but really adaptable, external. There is the first concept, which enduring concept. They are stable, nobody can touch them. And the third concept is a tangible concept, the one we can see. And we unfortunately build our system on all these concepts. So if you merge any technology and if you do anything without knowing the first two concepts, you're actually going into a dilemma of a lot of problems. Does this make sense? We build everything now based on tangibility, which is actually the thing I can see. And unfortunately, we don't understand many of the knowledge about that too. We do it we try by making mistakes until we get into a point, it seems like we're going to take this car and make it fly, for example, as a vehicle. Now, coming out to the concept, all the concept I'm talking about here, I have 50 ultimate key for each one of them. You see? And more. So we're talking about the first ultimate key, which is very important. The first ultimate key is actually called an ultimate goal. Every concept has an ultimate goal. They're all there. The majority of concept has one goal, each one of them. And the other few concept has two goals. Some concept has three goals, means the concept with two goals are two systems. And I'm dealing with every concept here as a system. And I could build a wonderful technology with it, and we'll build the application, and this application would be an engine. We don't have to, and we're going to talk about that. And, and this is actually very important to really know that. Now, this is the idea here, which is very important. There is a lot of other things I'm going to talk about as a key and give you examples. And of course, I would hope the conference, I did ask them to deserve 2 hours of question and answers, because I'm going to offer you opportunity to work with us, with my company. So I'm really creating teams, and those teams are going to be getting paid and work, and actually they become a branch of the company. And I'm going to show you some data, and actually I would be happy to put this with my record on YouTube. So coming to the ultimate goal, since I said that, and this ultimate, every point of information I tell you, nobody knows new information. So take the project, any project. Any project means any project from the beginning of life until the end of it have one ultimate goal. And actually they have other goals. This other goal, we call them, they have a very negative and very disastrous outcome. But if you know the goal here, you will know, and you have to be, if you like to really discuss with me, I would be happy to, because actually the abstraction of any goals, for every word, we do a lot of work to come up with that goal, which is we do the art of abstraction for finding the ultimate goal. And actually we do the art of abstraction for any other innovative key. So the goal, most of the people, when I ask them, what do you think the goals of any project? Most of the people say, for example, education. Wrong. Making money. Wrong. The goal here is an enduring concept, by the way, and is when. I'm going to give you example of 1 and 2 and 3. So the project, the ultimate goal for it is needs. Do not build any project until it has a need for it. This is all on all levels, individuals, government, organizations, families. Do not do any project unless you need it. And actually, getting married, you need to get married. This is a project, by now. You want to buy a car as a project. Get a car you need. Do not spend your money on a car just for really the fun of it. It doesn't make any sense. Anyhow, are you convinced about this? If you want to discuss it more, give you another example. Do you know the ultimate goal of any proposal? As an academic, we write proposals. And actually, the funny thing, we don't know the ultimate goal for it. Of course, the floor is open if you want to participate. So you must know this ultimate goal, otherwise you go into the wrong direction and you spend a lot of time writing proposals. And this proposal takes a lot of time and energy and collaboration. And you get, at the end, you're not going to get it because you don't know the ultimate goal of the proposal. That ultimate goal is actually the beginning of building the requirement, function, and non-function requirements. Look at this one here. So what the ultimate goal of any proposal? People say is actually to get money, to get funded, to really, stuff like that. People would agree with you on something, to do a movie or do, a play, you write a book. That's why all this stuff has a proposals. The ultimate one of the proposal, write a proposal to be accepted. So the ultimate goal of a proposal, acceptance. How many people do proposals every day? Billions of proposals happen daily. And actually billions of them fail too, by the way, because they don't know, they have to prepare themselves when they do a proposal, the proposal to get accepted. If you get rejected, you're wasting your time, you're wasting your energy, you're wasting everything. See the value of one key. Give you an example of two. We have knowledge. Knowledge have two ultimate goals. Believe it or not. We have MAP. MAP has three ultimate goals. And means means three systems. So we take the MAP. MAP is a very important piece of knowledge. We use it if we have a lot of different maps. A lot of scientists create maps. Country has maps. Your house has map. Everything has maps. But we must know the ultimate goal for each one. So to tell you, the one map for navigation, this is one. The other one for recording. We have to record everything about our houses, our countries, our, everything, even our plan. I have to record it. I have to really make sure this is recording. What's the third one? Knowledge. Well, I have a book called Knowledge Map. Knowledge Map to do a new innovation of domain analysis. This idea creates a lot of new technology, a lot of new projects. And actually, I would explore some project with you because I would like people to start building conferences and ideas, their own ideas. Why do I copycat United States or Europe? I have to copycat myself, the stuff I want to do, not copycat anybody. So I'm building things which is actually very enduring and systematic and stable. See, a lot of technology came out of this. This is for goals, for example. Well, resource has one goal. One important goals. We're wasting a lot of resources everywhere. Time is a very important resource, wasted all the time. Ourselves are resource. We're wasting ourselves. You must know the goal of resource because you are a very important resource. You and your people and your country and everything. And this resource actually make the wealth of you and the wealth of countries. So the best way to know is to utilize utilization of this resource. And this utilization has quality factor to control it and to evaluate it and do things like that. That's an ultimate goal. This, of course, we're talking about millions of concepts here. How about if really the impact? We found out, this is a study for every concept has, if you really have the right goal, you have a positive impact. And we explore many different things happen to show if it's negative impact, this is they use a different goal, which is actually they call it the bad goals. This is again something with the study, we did that for this, and this is actually very important for us to know. The concept has also non-functional requirements. And this is non-functional requirements is the element technology. Non-functional requirement means the quality factors. In software and many systems we build, we don't build into it the non-functional requirements. So they tell you software is reliable. I guarantee there is no any software is reliable at all. Don't believe this. Software is scalable. This is crazy. This is actually my field of knowledge for the last 45 years. I'm building courses about knowledge and software in machine learning and everything, and I'm building engines. The existing software courses is a bunch of crap. They're not engineering. You see, there is a lot of really pitfalls and major problem of our knowledge. That's why I'm bringing knowledge here to enhance the knowledge of humanity. And I wish everybody to participate. Coming back to the non-functional requirement. Non-functional requirement, at least in the field of software engineering, and the field of software engineering is everywhere. You build a car, software is there. You build an AI, software is there. Software becomes the biggest industry in the world. And you must get into it. I know in India, for example, they do in a house of rebuild something. And actually, this is outsource a lot of project there. And they actually a bank of coding. What we call it an assembly line. No, software has all the creativity in it. It has all, you can capture the wealth of the world by doing software. So we have to build this non-functional requirement into the system. It has to be executable. At this point, we don't know how to really define non-functional requirement for any system, for any concept. This is take also an art of abstraction to define it, to come up with it. For example, a question. You said violence. Everybody hates violence, correct? Do you agree? Yes, if you ask anybody, you say violence? No way, it's not me. I have nothing to do with it. Violence lives with us. And actually violence is part of us. You know, you get sick, you really feel bad, you feel, this is all a form of violence. You get abused or you abuse somebody, that's a form of violence. Violence is actually attached to us. Violence, we actually as a human, around our body and on top of our body and inside our body, a lot of really many different life beings like microbes and garasim, a lot of stuff like that. And they're all dangerous. I think no, 90% of them are dangerous. But you already have a system here, it actually cleans the air when it comes into your system. Violence has 3 quality factors. Violence is a goal of itself. Does anybody knows this? I'm going to give you an example. Violence has 3 quality factors. Let me give you an example of violence. We have a lot of forests here in California. And suddenly it happened to be fired in it by itself. This is kind of really something happened in reality. You know, this is a way of really evolving or maybe coming up with a new forest. So it has 3 quality factors. What is the quality factor? And first of all, it causes a change, complete change. That's one quality factor. It's renewed, become very new forest. Third, it having growth into it. So this happened with a human being. Human being, when actually violence in marriage, for example, if this marriage doesn't work, they find a different marriage, then they become a change happen, renew the wife or the husband, as well as growth would take place. Because living in violence means you are disabled. This is again proposals. Proposal has 4 quality factors. When you write a proposal and actually do anything to really get the proposal done, you have to really aware of these quality factors. And all of them has to be in the proposal. So for examples, if I really want to write a proposal, I must write a proposal to get accepted. I would not do it. Otherwise, I would really be crazy, wasting time. Now, there is quality factor would really be written in a different ways inside that proposal. One, just write these notes, please, because you're going to write proposals. Life full of proposals. The worst one, first one, the proposal has to be convincing. Because again, you seek acceptance first. You have to convince the reviewers and the people that read the proposal. They actually have to really think you are a genius by convincing them. The second one, you have to be focused. Most of the people actually writing proposal, they go left and right, they write a lot of stuff. The proposal has nothing to do with the proposal. What's going on here? You have to focus. Proposal means if you go to really ask for the hand of a woman, focus on the woman. You focus on the idea when you write a proposal. This is actually, the proposal must be doable. I have to submit a proposal I can do. Because again, the reviewer is not idiots. If you cannot do it, you go and promise to really ask for the hand of the lady, then you promise her to take her to the moon. The people would laugh at you. It's impossible. Just you have to be real. So I would be able to do that proposal. The fourth one, you get approved. So I wrote a proposal for $1 million. And I got a letter said, we don't have enough money. I'm serious. I called the NSF saying, what's going on here? And I was very upset. They said, Mohammed, your money coming next year. Because again, of course, you know, they give the people with favor the money, and actually I would really stay to it. It's been approved, but my money coming next cycle. This is actually, you have to write a proposal to be approved. And this is the award for you. 4 quality factor if doing any proposal. Even if you ask somebody out for dinner, include these 4 things there. If you propose to somebody to be a friend, that's a proposal. If you propose to go to build a movie, this is really the 4 things you have to watch out for. See, this is very important. This is non-functional requirements. I don't know if the time going very well here or not. So, other keys. But in this non-functional requirement has 13. Each one of them has 13 innovative keys. So you know, if I know the functional requirements, the non-functional requirement, this functional requirement require actually a technical work. I like to teach people how to do it because you build system that way. And actually the dilemma for functional requirement, we build system with no functional requirements. Most of the people actually in their books, we really know the functional requirement, you know nothing. I'm serious. So because again, if you know the functional requirement very well, we don't have problem with reinventing the wheel. We don't have problem with maintenance. We don't have problem with actually building the systems all over and all over again for different instances. It doesn't make any sense. So if you have, this is a very big dilemma in industry. I have to have the function and non-function requirement. This is missing from industry. This is missing from research. Coming to the non-function requirements. This has 13 innovative key. So I could really be having a system to evaluate the evaluation. I have the way to evaluate. I have to measure. This is another one. I have to define the system because again, all the definition exists for any system or any concept is contradiction. And everybody really create, is a scientist, create his own definition of things. And they don't make any sense. You see? So this is 3. It has to be positive. So the goal can be negative and positive. But the non-functional requirement has to be positivity. Well, there's other things too. Branding. This is control, because if you have the function, non-function requirement, you control the function requirement. And this is, again, I'm going to come to the issue here with, I wish I could really explore all these keys with you. What's really the non-function requirement of you yourself? Do you believe it? Human define for themselves 2,000 non-functional requirements or quality factors. You keep wondering, is this people crazy? You know, by the way, and I believe certainly after this study, the study I do for many years, the human is a class by themselves. It's unfair to put human as part of animal kingdom. You're not an animal. I'm not an animal. All the rules, the way things we do with us in privacy, in life, they treat us as an animals. Because actually that's what the biography, the biology said. And actually some idiot come and actually say human is actually come from originally from the monkey. It doesn't make any sense. So the idea here, I have proves human are really a class by themselves. And actually there is no difference between a human in anywhere. All human are the same. That's the 3 quality factor there. Is you know them, you must know them. Because you and me are human. They say in different countries who don't have humans. They're joking about themselves because they don't know the 3 things there. So what do you think the 3 quality factor of human, which is actually make them unique than any other creature? Human as a concept. I'm talking about human, of course, it's applied to us because we are a human. So what are really the 3 quality factor there? Is anybody knows? Open the floor, maybe I could really get somebody to respond. I don't know if really I have anybody write anything in the chat here. No. So let me know. I'm here. This is because I have 2 hours. I would be here after the lecture. You could attend and actually be asking me questions and actually ask me how you collaborate with me. I have a tons of jobs for everybody. And I have a tons, I would like to make a branch for everybody, everywhere. So to human is to be selfless. This is one of the 2,000. Very good. Now we start actually abstracting the 3 quality factor of a human, which make them unique than anybody else, any other creatures. And you know the creatures of types, of millions of types. Millions. We are one of those millions. We are very unique. So somebody wrote selfishness or maybe selfless. This is one of the 2,000. We have a lot of really, I cannot evaluate any human because again, this is insane. We have to be evaluated in many different ways. The way we evaluate in work is unfair. The way we evaluate based on our race is unfair. The way we've been evaluating people everywhere is actually has a lot of discrimination, a lot of junk into it. Humans are the same all over the world. There is no difference between you and any other human elsewhere. This is actually, that's what the 3 quality factor must be taught to people. This 3 quality factor, by the way, every quality factor for a concept is a big book. Has 14 chapters. And every one of them is a very part of a big course for a human, or for proposal, or for projects. So, somebody said here, really an enlightening sessions, provoking different thoughts. Indeed, we have to start to actually communicate. We have to start work together and come up with something to help us. This division, no need for it. This is a true field of knowledge. So this is actually very important. Thank you. This is very good. The unusual technical, yes, that's a technical speech, sir, by the way. Very highly technical. And building teams everywhere. And I have a story of teams because I'm writing proposal for SBIR for a $10 million to do this in the United States. I have the proof now, and I would like you to get involved. Everything we do from the 50 key word here is belong to everything we do. Industry, technology, our life. This is technical. And actually I could prove it with logic and math and everything. Because actually we're dealing with issues, just actually I call it ink on papers. You give me a paper and I could tell you what's wrong with it. And every technology exists has a lot of problems. We don't know how to solve it. And this is actually start with this. That's why when I say the concept has what we call it haraj and maraj, means this is actually habub. Habub in English means a lot of different junk about the concept. Humans have the same. Country have the same. See? That's why the concept is equivalent to a life entity when you use it. The concept has a lot of properties. You know, we don't know how important each concept is. We don't know this another key, which is actually the responsibility for the concept. The concept has roles, and you have to really know how the type of the concept, which I talk about that time. It's all technical work, and I thank you for the note. I appreciate that. And if you use this in your research, you'll be a winner. You'll be a true gurus, as in Indian definition of gurus. I love this term a lot, by the way, because our civilization built on gurus. And this is what happened. Indian civilizations, Chinese civilization, Egyptian civilization, built on gurus. And these gurus will be known worldwide because they know what they're doing. Thank you for the comments. I would like to really tell you about another technology because, again, I generated a lot of technology from this work. Do I building this technology? Yes. For example, application. Look at this assessment and read it very well. Application object of application systems is going to go away. Why? Because application system, by the way, they are really huge. They all have dilemmas. I want to replace it with, because I know how to do the requirement, with engines. So it's going to be application system we're building now is going to be part of history. The new coming here is unified, and actually the technology called that unified software engine use. Actually, engine use, and building a lot of projects nobody done before. And it's going this engine, I could build on top of it as many instances of the project anywhere. Like the like Facebook, like LinkedIn, I could really build a lot of stuff on it. This is very trivial what they have. For example, if I have a debate, do you know what the ultimate goal of debate is? I'll be honest with you, the answer, no. You're not only a scientist, you are a thinker too, by the way, because you do research to help the human. We have many software for debates. I could have one platform, and this is with their foundation. You could build any debates on it. This meeting here, I could meet with a lot of people easily if I build that. If I build this foundation, it's very easy to do. So the idea here, I'm building this foundation called Unified Software Engines. And I'm right now building an engine for contracts. I'm also building an engine for a web applications or websites. Because again, what the website we have, you have to buy a lot of stuff for it. So you provide you the website, then I have to abuse you. You buy Grammarly, you buy trends, you buy data mining, you buy, this is amazing. This is nonsense. I could really do mining in everywhere by doing, this is part of the website. So I could create the website and actually make it, wonderful every day. So what's the goal of really websites? Nobody knows. There is one goal for each website. The ultimate goal of website is actually, or interface, is an interface. Is actually look and feel. Look good and feel good. Believe it or not, yes. I want to build a website, look good and feel good. Like when you present yourself as an interface, you look good and feel good. You see? So I think my time is actually coming up here. Unless, they told me an hour, but they put me a schedule for 40 minutes. I'm up 4 minutes. So if you have any questions, I'm here. Please ask questions. Also, I would love to do a session for give and take, and also propose to you an idea of building teams to do this work. And everybody gonna get paid, and everybody gonna be collaborating, and everybody gonna get serious in business here. You say this conference, for example, I'm sorry to say that, I've been in 52 countries. Everybody copycat, United States and Europe. Why? And actually we're doing the same thing. So the paper you publish here, why not to be in top journals? Why not to be in top journals? Rank number 1. Because again, your publication and your research is very good. It has to be done in a way everybody get his own share and plus contribute to our humanity. Do you understand? I'm not putting that. This is again, no. I came here voluntarily and I love I come here. But the idea here, I'm telling you, look for a change. I have my own technology. Software is the most important technology. What I'm telling you here was language, by the way, and linguistic engineering and linguistic computing. This is a very top technologies. Because again, we need everything we build, understand us, communicate with us, be smart. We have a lot of problem with this. You see, we are very valuable. We try to do this in a robotic system and a smart system to imitate small part of us. They don't know how to do. They have a project to do a artificial brain. I joke about that. There is no way. This brain is actually very complex. There is no way. Your brain is a gift from God. Your brain is actually would make you wealthy everywhere. Economical wealth, intelligent wealth everywhere, in every field of it. This is up to you. There is no way anybody can imitate that brain. So the idea here, I really done, unless you have any questions. And if they have a session after that, I would be happy to meet with all of you. And actually, let me see this statement here. Very good. Being in professional life, over times we lose touch from such moral. Very good. You lose this. And let me tell you, this is very important. There are three fundamental assets, essential property of human of life. Three: work, knowledge, and morals, which you call it ethics. Can each one of you please make them in the right order? You will discover things we do very poorly. Because again, this is what really the morals here, and actually the moral motivations, we'll call it different things. We'll call it in field of science and engineering, ethics. In ethics, we have one credit for ethics. And by the way, if I really repeat this for you, in a logical way, ethics is the first one. If you don't have this ethics, you have no knowledge, you have no work immediately. Ethics considered to be 60% of all essential life, the way we live. Without ethics, everybody's gonna go boom, gone. Then you have knowledge after that. Then after that, you have work. Unfortunately, most of the people doesn't know that. I have a lot of videos. I'm gonna come about this because unfortunately, everything happening in the world now is no ethics law. Unfortunately, even the relationship between people, between families, between business and people, business try to really abuse people and take their money. And they talk business ethics. Excuse me, where is this business ethics? There is a group of people try to really take all your money, all your time. And I work for a company, they work a lot less. They give you a lot less than what you contribute. You work, you contribute to their wealth, but you didn't get wealthy. There's a lot of things we have to really reform again. Very important. So that the sequence of those things would be morals, the first one, 60%. Knowledge, 30%. Work is 10%. Because if you know the first two here, you really do the work very easily and smoothly. It really can be science and knowledge without ethics. Yes, it exists right now. It's going to be work without knowledge and ethics. Yes, unfortunately. That's why we have a lot of con mans, con organizations. And actually they come to work, they actually after your bucket, they have to really empty your bucket for money, and that's it. Unfortunately. So the idea here, this is a science thing. This is very important for everything we do. If we build a technology and system, it has to be ethical. Then it has to be knowledge into it. And actually it has, after that, you really have to put it together and work. And this question, by the way, being debated in every field of knowledge. In software, they call it art or science or, or engineering. Excuse me? Software, by the way, has every field of knowledge, has art. This is, again, science and engineering. There's another three key words here. And actually, with this, you will find out ethics is an art of itself. And actually, this is the rules are supposed to be very clean. This is actually what it is. Science is the knowledge I'm talking about. Engineering, you put it to application. Every field of knowledge is that way. So we have to look at this. We have to make sure, I'm really done. I think I took more than my time. If you have any questions, I think I have to read here. Such a morals value can keep one motivated to work. Yes, I'm 72 years old. I work all the time. I'm still young. This is again, I tell people don't return into retirements. You actually can kill yourself that way. You are gone. Keep young, work, keep thinking, keep producing, do research, live life and enjoy it. So the idea here, thank you, this is a very good thing. And I really like this, thank you for really, they try to tell me by really a nice word, stop. So I am really, if you really have a session after this, I would be happy to participate and actually answer any question you want. I want to thank you all. I want to thank the organization of this conference. And I enjoy myself a lot with you. I wish I would really have a presentation. It would really be very focused on one area. But again, I'm hoping before I leave, I build a lot of teams. And I'm willing to talk to you about these teams and provide you documentation for it. I did ask for that, but I don't know if they would really allow. Can you allow me the meeting with participants here? Daya?
Yes, sir. Yes, sir. Definitely.
Yes, please. Okay, I'm here. So the initial meetings, please tell us what time, and actually I could really be able to help and be able to answer questions.
Sure, sir.
Great, thank you very much.
Thank you.
Any questions? Yes. Okay, please send me a copy of this wonderful talk. I'm sorry. You actually like it. It seems like it. You can send me a thank you note. I really appreciate it. This is very, very good. Okay, I would like to share this everywhere. So next year, probably with this event would be a lot bigger and bigger. Okay?
Definitely, sir.
So yes, okay. I'm waiting in case we have a discussion. I'm open for it.
Yeah.
Thank you very much. I thank everyone in this conference. I love India. I've been in India many different times. And then usually I go to Delhi, the University of New Delhi. And I like the people there a lot. I enjoy myself a lot in India. You are great people, my darling. Thank you very much. I enjoy talking to you. And I'm open to questions. I left an email. Please communicate with me. Thank you.
Yes. Thank you so much, sir, for your valuable speech. Thank you so much, sir.
Thank you very much. All right. Bye.
Bye, sir. Thank you, sir.
You're welcome. Thank you. Do I have to leave or what? Actually, I would like to. You didn't stop it's still live. So I want to attend the rest of the conference if you don't mind. And actually, I would say the slot. I would like to meet with people if they desire to. Thank you very much. I appreciate it. Very inspiring and knowledgeable views. Very thank you, sir. Appreciate it. We want to turn it into a very valuable technology to help everybody because the language has a tank of knowledge. And also the engineering. We try to really make it engineering. And ethics too, by the way. So should I wait here or should I do?
I think I'm the next one in line to speak, Dr. Fayad.
That's fine. I'm done. I'm done. Thank you. I would like to learn about the other speaker. That would be very good. Thank you. Should I leave?
No, you don't need to leave. I think they will arrange.
It's okay. All right. Thank you.
Sushmitaji, are you going to pipe me in?
Yes, sir.
Hello?
Yes, sir.
Yes.
So shall I start the video?
Yes, sir. Now we can welcome Dr. Sethi.
Yeah. Okay, sir. Thank you, sir. I would like to welcome a keynote speaker, Dr. Sethi, sir, Sanjay Sethi, sir, founder and CEO from Antardavani Incorporated, St. Joseph's, Silicon Valley, California, USA. Welcome, sir. Dr. Sanjay Sethi, sir, has 25 years of proven versatile technology leadership in the semiconductor industry. Engineering and business development, he completed his PhD in high-speed optoelectronics, University of Michigan, Ann Arbor, nominated for Best PhD Dissertation Award in 1995. He has experience in high-performance analog or mixed signal circuit design, hardware development, and embedded system engineering, single integrity packaging, broad design also in on-chip power and thermal management and semiconductor. Process development of high-speed optoelectronics. He is well-versed in technical sales in enable significant top-line revenue growth over S350mm in ASIC designs wins. Experience in new product development and data converters like ADC and DAC for wireless and wireline applications. He has technical sales enable significant top-line revenue growth over S350mm in SiC design wins. Heartily welcome you, sir.
Thank you. Thank you very much. It was a pleasure to hear the last lines of Dr. Fayad's talk, where he talked about ethics. Let me start with a shlok from the Bhagavad Gita. This is shlok 50, chapter 2 of the Bhagavad Gita. Buddhi yukto jahati ubhe sukrita dushkrite tasmad yogaya yujjasva yoga karmasu kaushala. The translation, of course, I have to give you, is one with intelligence attuned to yoga outlives both virtue and vice. One with intelligence attuned to yoga outlives both virtue and vice. Therefore, dedicate yourself to yoga. Yoga is verily dexterity in performing all kinds of actions. Yoga karmasu kaushalam. My keynote address, Sushmita ji and Meena ji and others, is going to be a different one. It's going to, I intend to do my best to inspire the students of this fine engineering institution to get them to do things which nobody teaches in these institutions. I never learned it in these institutions. I spent my 4 years in Pilani. I went to BITS Pilani, reading the Upanishads. And that's where I got this, not from any classes. And when Dr. Fayad talked about ethics, I look at a few characteristics of anybody who I work with. I do not work with anyone who does not possess these characteristics, period. Starts with character, and character includes integrity, compassion, and ethics, of course. Somebody who does not have competence. This is all neti from the Gita, right? Someone who does not have good judgment, someone who does not have good attitude. These are the qualities I look for. And of course, overriding is intelligence. If you do not have intelligence, everything is wiped out. So on that happy note, I'm going to start sharing my screen and share whatever little I can contribute. As I said, it's going to be a little different. I think Sushmita ji is aware of how I talk. So let me start. Can you see my screen?
Yes, sir. We are able to see.
Thank you. So the name of my company is Antardhvani. And Antardhvani means inner voice, your inner conscience, your Atma. It comes from Mahadev. Mahadev, who created sound, and it's a play on ultrasound, and the company is about ultrasound. But I'll talk about other things as well, about compound semiconductors, about systems design, a little bit about life, not too much gyan, but hopefully I'll be able to convey what I want to. So let's go to the next slide. Let me introduce myself. Sushmita ji, can you see the slide which talks about my skills, etc.?
Yes, sir, it's visible, sir.
Thank you. Thank you. May I know your name, sir? The one who's responding, the gentleman who's responding to me?
My name is Avinash.
Avinash. Thank you, Avinash ji.
Yes, sir. Thank you.
So, in yellow are my hard skills. In white are my soft skills. I am not touting a trumpet here. I am merely conveying to the students of the school, because I primarily believe this is an engineering school, that what are the qualities that it takes to be able to do anything significant in the world. You cannot be a one-track individual. You have to be diverse. You have to have all kinds of skills. And I was fortunate enough to have acquired various skills along the way. Let me minimize this window, which keeps showing the different people on the call. Let me see how I can do that. Because apparently let me see how I can do that. Oh, 1 second. All right, I can do that. Good. So the journey of my life started from my high school, the Hyderabad Public School. And I only mentioned that for a very simple reason. Alumni like Satya Nadella, the current CEO of Microsoft, Shantanu Narayan, the current CEO of Adobe, people like the Warren Buffett of Canada, Prem Wadhwa, these people are from my school. And I'm very thankful to have received a very fine education, multidimensional education, not just academics, but things like debating, quizzing, various capacities. Unfortunately, I didn't play much sports. That's another story. Then I went to BITS Pilani, and BITS Pilani's motto is Gyanam Paramam Balam. Knowledge is power supreme. So that goes to Dr. Fayad's point. You have to have knowledge. You have to have competence. You have to have ability. All the ethics in the world will not save you if you're an idiot. So you have to have both. And you have to have good judgment along with that, and attitude, various other things. Then I came to the US to get my PhD. I went to RPI, which was the first school in the US to have given an engineering diploma in civil engineering in 1824. I worked in high temperature superconductors and in photovoltaic cells, solar cells. Transferred midway to Michigan, Ann Arbor, the University of Michigan. And I worked on, at that time, things change in the world, but at that time, the world's fastest lasers and photo detectors and photo receivers. And my PhD was nominated for the Best PhD Dissertation Award. Very kind of the Lord. And the journey is not as simple as that. So I would like to enjoin upon the students that nothing is linear. I went through hell in my PhD. I tried to quit it about 6 times, I think. So don't imagine that it's a straight walk-in. I was the first student from Michigan to be admitted to the IBM Research Center, the Thomas J. Watson Research Center in Yorktown Heights, New York. All the Nobel Prizes that IBM has gained are won from that august institution. It is the equivalent of Bell Labs for AT&T. Bell Labs is dead, but IBM Research still exists. Few companies that I went through: Texas Instruments, AMD, Toshiba, Global Foundries, G Digital, which is not a semiconductor company, Synopsys, and now I'm working on it. Journey of life takes you through various things, and I'll just briefly touch upon these things. Technical pre-sales, solutions architect, building ecosystems, partnerships, business development, execution, which is program management, getting things done. I always say, I know how to do things and I know how to get them done. God has been kind. And my fundamentals are in circuit design, IP design, chip design, and systems design, and applications engineering. Along the way, there's packaging, signal integrity, and power integrity. PhD is in photonics. My work at IBM was in silicon photonics. IoT, I assume most of you know about it. I did a quick scan of the papers that are being presented at this conference, the Internet of Things. And during my PhD and then later as well, compound semiconductor and silicon process technology. But you see, these are not sufficient. What is needed along with those is these other three buckets in which I put my skills. And believe me, again, I'm now not touting my trumpet. I'm not blowing a trumpet. I'm just letting you know that you need to build upon these skills as well. And sometimes people perceive you as having achieved these skills, and sometimes they perceive you as not. The world is full of politics. So don't assume that it's all rosy and shiny and you do all these things and you're guaranteed to have a wonderful life. No, you're not. In fact, you're guaranteed not to. So execution in an atmosphere of innovation, which is what the Silicon Valley is about. I'm trying to give you guys a picture of Silicon Valley, which is considered to be, well, Bangalore and Hyderabad, where I come from, are now considered to be the equivalent of Silicon Valley in India. It doesn't matter what these titles mean, what these logos mean. The fact is that you have to execute and you have to innovate. You have to come up with new things. You have to change people's lives. You have to add value. So you have to understand people, strategy, operations. I won't talk too much about this. This will become a long lecture otherwise. But you have to understand the big picture and the details. You have to understand the business. You have to understand the customer. You have to understand the technology. You have to understand the competition. You have to know your people. You have to understand the customer's needs as opposed to their wants. You have to be able to build trust. You have to know how to communicate clearly and set expectations. You have to know how to follow through. You have to know how to reward your people. You have to know how to mentor and grow your team. And problem solving is essential. In engineering, which is where you are from, if you don't know how to solve problems, just go get an MBA. I almost got an MBA. I was admitted to IIM Calcutta. Fate decided otherwise. My father took the letter of admission and tore it up. So I came to the US to do my PhD. But you really have to know how to solve problems, whether they are technical problems or business problems or people problems or execution problems. And you have to know how to get to the root cause of issues. And of course, you have to we won't dwell on this, but here is Antar Dhwani's mission statement. So what I'd like to say is that my current phase in life is I'm working to build a startup which is going to transform healthcare and upend the toxic medical community. I underwent a lot of toxic treatment at the hands of the HMOs in the US. And that's what forced me to start this company. This is basically going to transform ultrasound and take it to about 1,000x at least improvement in resolution, penetration depth, quality, and usability. It's going to be a portable. You can keep reading this. I'm not going to speak to it. You can all read it. But it's going to be a portable device. It's going to be an implantable device. It's going to transform things like breast cancer. Can you imagine that 75% of all breast cancers in the world are being caused by the mammography that doctors inflict upon women? That low dose, quote unquote, low dose X-ray radiation is causing that kind of damage. And ultrasound is a purely benign technology. It's acoustic technology. You basically convert electrical impulses into acoustic signals, which then go penetrate the body, bounce off, reflect off various organs, come back, get transformed back into the electrical world. And now, voila, you have images and you can now figure out what's going on. That's the diagnostic end. And I'm going to take your existing carts. It's a cart-sized device right now at about $135,000. I'm going to make it into a portable device, which is going to be less than $1,000, less than your smartphone. Of course, I'm not competing with smartphones. China knows how to build smartphones which are less than $300. But be that as it may, we can send out postmen out into rural India, rural Africa, rural South America, and they can take untrained, they can take 4-dimensional scans. Why 4-dimensional? Because the added dimension is time. So you can take video shots, and there'll be holistic shots, and they can be analyzed either in the cloud by experts sitting in, for instance, the University of California, San Francisco, which is recognized as a probably the world's best cancer treatment center. Or I can put artificial intelligence and machine learning into that handheld device, and we can diagnose right there on the ground whether that growth is benign or cancerous, malignant, or it's a fracture, or the fetus is growing normally, or what have you, any of those. There's also a feature of this. It can diagnose COVID. We don't need to go through the ultra expensive and long durational PCR tests to detect COVID. And we don't have to go through toxic CT scans to monitor patients. This can be done on a very cheap basis, and it can help alleviate the COVID problem that's going on in the world today. There's also an implantable. I can actually take a portion of this device, and I'll show you in a moment what it is, because after all, this is an engineering talk. So I'm going to show you something about engineering as well. And I can put the detection and transduction portion into such a tiny microscopic form factor that I can put it through the syringe of a hypodermic needle and insert it into veins, and then monitoring the blood flow, whether it's laminar or turbulent. One can monitor and determine whether you're going to have atherosclerosis or a cardiac arrest 6 months, 6 years from now. So it's truly a radical transformational technology. And as I mentioned here, why ultrasound? You can look at it very quickly. I've listed about 30 use cases here. There's lung imaging, there's cardiology, there's Doppler techniques, and that was only the diagnostics. There's also therapeutics. You can perform surgery. You can actually go in and with focused ultrasound and directed ultrasound, you can go in and pulverize kidney stones and not damage the surrounding tissue. And that tissue is safe. The stones are pulverized to dust, and they can be passed out, excreted through the urinary tract. So there are so many things that can be done. It's amazing. And it can replace MRI, it can replace CT scans, it can replace PET scans, because it actually can go through and detect soft tissue, not just hard tissue. X-rays are confined to hard tissue. You can go into soft tissue as well, which is what MRI does. And MRI is extremely expensive. And that's what I suffer at the hands of these people who call themselves doctors. They are money-making machines. They're not doctors. That's what the world has become. This is the engineering diagram that I wanted to show you so that you have some glimpse of what it takes. I believe that there are a number of, Avinashi, there are a number of electrical engineering students here. Correct? Avinashi.
Yes, sir. I'm
There are a number of
Sushmita.
electrical engineering.
Yes,
There are
sir.
a
I
number
can
of
see.
Yeah, I'm asking if there are a number of electrical engineering students here. Are there? Are there electrical engineering students in the
Sir,
audience?
around 25 students.
Electronics, we are from electronics, sir. Electronics is there.
So electronics comes under electrical engineering. There's this misconception in India that
Yes.
electrical engineering means motors and generators and transformers.
Yes.
My degree is in electrical engineering, and I've done solid state electronics. So please, this is highly stupid in India that people think that electrical engineering is to be looked down upon and electronics is a great thing. I have gone through this. There was electronics and communications used to be a separate discipline. Luckily in Pilani, it was called electrical and electronics engineering. It was a combined degree. So we learned both.
Yes. Yes.
And that's how it should be. So as you can see here, can you see my cursor here?
Yes, sir.
Okay. So this is the transduction end, the transducers. These are hundreds of volts that are being sent out. These pulses that come in, they're converted to acoustic impulses and sent out, as I explained, into the body. And then they're reflected and brought back, and then they're converted back. As you can see, there's a transmit path and there's a receive path. And then that receive path goes through a lot of very, very complex, very low signal. So it's very precise, very accurate, very difficult analog signal processing. Because once you send that signal out, it comes back attenuated. And stop me if any of you don't understand the terms that I'm using here. I would assume that you all know these terms because you're engineering students. And these signals that are converted, then they have to be converted to the digital world through these ADCs, A to D converters. And then they go through digital signal processing and Doppler processing, various forms of algorithms. And then they're converted into images. And that's when you see those images. So it's amazing that all these things work. It truly is amazing. It's a very old technology, starting in the 1900s with sonar, but the transformation is happening as we speak. And current ultrasound systems have a number of issues, some of which I've listed here. As I said, hundreds of volts of amplitudes of the signals that are sent out. The major issues with resolution, with quality of the image. The signal path is, as I said, very complex analog components, which deteriorate the signal quality. SNR is signal to noise ratio. And it's very expensive because of this. And Antardhvani, I'm targeting 3 applications for it primarily to start with. One I mentioned earlier, which is COVID. The other is mammography and tumor detection. The third is IVUS, or intravascular imaging, which I mentioned is an implantable device, which you can use to detect things like atherosclerosis, which is buildup of plaque in the arteries, which leads to a heart failure or a coronary thrombosis, or something like let's say a hole in the heart. One can detect a hole in the heart, a tiny microscopic hole in the heart, years before it actually becomes something of significance, and you can solve the problem at its root. Now, I come to the second part of Antardhvani. The first part is the medical device. The second part is the semiconductor end. You remember that I said, let me go back to this picture, which I was showing you. This picture, right? There are 2 parts. One is the transducer, which is the component that both senses the acoustic wave that is being reflected and sends out the pulses. That's one end. And then the other portion is all the detection and signal processing end, right? Now, my expertise is in semiconductors and chip design and analog design and signal integrity and high-speed signal interfaces, but also in building devices. And so I come to the second part of the company, which is here. Let's look at this with a fresh insight and see what is going on. There is a global crisis that is happening right now, and the world is recognizing that there is a crisis with regard to semiconductors. And that's happened because of COVID primarily. And what's happened is that the 2 to 3 big manufacturers of semiconductors, TSMC, which is Taiwan Semiconductor Manufacturing Corporation, and Samsung, they now possess 71% of the total available silicon wafer capacity. And during COVID, nobody was driving anywhere, so the automobile industry pretty much shut down. And so the demand of those chips went down, and the semiconductor industry adjusted to produce chips which would be used for watching Netflix, buy cell phones, talk to people, because you couldn't go and meet people. And so consumer electronics started dominating. And as a net result, today, when the semiconductor industry and the automotive industry related to that is taking a resurgence, there is no more capacity, there is no more inventory for these chips. So there's a huge glut. In addition to this, people are finally recognizing that there's a geopolitical reality. China, and we should be all afraid of China. And I speak as an Indian and I speak as an American, both. Their agenda is very different. Their agenda is to take over the world. And they have no compunctions about what they do in that pursuit. China has already made several designs towards Taiwan. Taiwan Semiconductor Manufacturing Company, which is the largest semiconductor pure play foundry manufacturing unit in the world, is at risk. In addition, Taiwan is going through droughts, and it's an earthquake-prone region. So the US is very, very, very worried. And it's been reduced to 12% of the market share the US has. So now they're scrambling to pass the CHIPS Act, which is again in trouble, but they're desperately trying to pass it, to approve $52 billion to reinvest in the semiconductor industry. And you can see from the slide, I don't need to read it. I'm sure you can all read it yourselves. You can see what TSMC is committed to investing. It is investing more than 2x of what the United States government is committing to invest. And heaven help us, orders of magnitude more than what India is committing to invest. And let's not even talk about the EU. So this is the semiconductor industry. It's an inverted pyramid, as I'm showing it here right now. I'm showing the, can you see my cursor, Avinashji? Can you see the cursor?
Yes, sir. Yes, sir. Yes, sir.
Thank you. Yeah. So what I've done is I've put the manufacturing companies at the top of the pyramid. Usually it's at the bottom. But I'm showing it in such a way that you understand how important these manufacturing companies are. There's TSMC, there's Samsung, there's UMC, there's Global Foundries, which I've worked at. And then, 1 second, I need to plug in my computer because apparently the battery is about to die. Give me a second, please. Okay, we should be safe now. So there's the, let's go from the bottom up, okay? So there are these companies which enable the software and the IP that goes into these chips. I think Dr. Fayad was stressing software. Well, software is extremely important, but software is nothing without the hardware. Absolutely nothing, as the world is discovering now. So, sorry to say.
It's the opposite, by the way.
No, it's not.
Hardware can not do anything without software.
Dr. Fayad, we can take this offline.
Hardware is a dilemma of actually making software behind.
You have your opinions, I have mine.
It's
And
not
we're
an
both very
opinion, it's a scientific talk.
Please. This is not an argument here.
Yes,
it's not an argument here. We can take it offline. We can take it offline. The world is discovering that without semiconductor chips, nothing works. What steel was to the world a century or two ago, semiconductor chips are to the world today. And it's no accident that every country in the world is now scrambling to invest into semiconductor manufacturing. Software is extremely important. I'm not decrying that, but it rides upon hardware. And without hardware, nothing works. So there are these other companies which now give you the ability, like Mentor Graphics and Synopsys and Cadence. They enable you to design these chips. They produce the software that is used to design these chips. And then there are the supply chain companies, all these supply chain companies that enable you to manufacture these semiconductors, the wafer producing companies, the companies that produce the gases that you use, the companies that produce the photolithography, ASML, everything is gated by photolithography these days, because everyone, as they're trying to shrink silicon features, are confronting the fact that optics has a limit. And so they're trying to go more than more. They're trying to find other creative ways with things like chiplets to build systems. Then you come to the companies, the fabless companies here, like AMD, Qualcomm, Broadcom, IBM, Micron, Intel, Samsung, which is both an IDM and a fabless company as well, right? And these guys design the chips, which then are manufactured by the people at the apex of this pyramid. And I deliberately put this at the apex because I'm talking about a semiconductor manufacturing infrastructure that India sorely needs to possess, and that Mr. Modi is supposedly trying his best to invest in. And I'm looking to people here in this audience that somebody, I hope, will be able to recognize what I can do. And I'm going to show you that in the next slide, and what I'm looking to do for India. Now, silicon logic process technology at these advanced nodes is extremely complex. It's extremely capital intensive. A fab is more than $20 billion at 7 nanometer technology node. And it's almost guaranteed to become obsolete in less than 5 years. So you have a very short period in which to recover your investment and then make it profitable. It takes over 3 to 5 years to generate the profitability. And Intel has given up. They now manufacture their 7 nanometer chips and 5 nanometer chips through TSMC. Amazing, right? Intel led the semiconductor industry not so long ago, even 20 years ago. But TSMC has taken the lead. And what's happening is that something like extreme UV, that's what EUV stands for, extreme ultraviolet lithography, is being done by only one company in the world, and that's ASML. That's over here. And so people are being held hostage by this. There are so many barriers to entry that the semiconductor industry, let me tell you, is more complex than building a rocket ship. It's a wonder that semiconductor chips actually work. If you have contamination of more than 1 part in a billion, your chips will stop working. Can you imagine that? 1 part in a billion of contamination, the dopants will not work, your chips will not work. And this is only silicon, right? It's got human intelligence, knowledge, IP protection. People are not going to give you their intellectual property for free. It's guarded very, very closely by the United States. The United States is currently doubling down and preventing any of this intellectual property from reaching China. They're doing their darndest. They're exercising all their powers upon ASML to not release this technology to any Chinese fab. And TSMC has had to guarantee that it will not produce a chip for China. The supply chain includes not just semiconductor fabrication. There's a lot of things that ride on that. There's packaging, there's testing, there's yield management, all kinds of things in that supply chain. A simple thing like deionized water, ultra pure water, India does not have. Without that ultra pure water, as I said, 1 part in a billion of contamination will destroy your chips. And forget about the fact that you need uninterrupted power. Power goes down for 1 second and your entire semiconductor fab line comes down, unrecoverable. Hundreds of millions of dollars go down the drain. And technology transfer, as I said, nobody's going to transfer the technology. Silicon is in trouble if India wants to invest there. But there's hope. There's hope. silicon is not the only game in town. There's compound semiconductors. And compound semiconductors include things like indium aluminum gallium arsenide, indium aluminum gallium nitride, even things like silicon carbide, silicon germanium. So there are all kinds of compound semiconductors, and they are vitally needed for a number of applications. I know this is an eye chart, but please bear with me. There's no way that I can make this less complex. It is complex, and so you have to understand that. All your analog mixed signal circuits, all your radio frequency circuits, all your for telecommunication, all your millimeter wave circuits, all your power generation and power management circuits, your fiber optics for telecommunications, your Wi-Fi and your 5G and 6G telephony, your radar, your autonomous vehicles that you're producing, which use the LiDAR, which is a variant of radar, your satellite communications, as I said, your power generation, delivery, and management, all your military and aerospace applications. And I just mentioned sensors to you in Antardhvani. Well, those sensors are not unique to Antardhvani. Those MEMS sensors, micro electromechanical sensors, as they're called, are used in your car to deploy your airbags. Your airbag deploys because there's an accelerometer inside that steering wheel, which senses that you've come to a sudden halt, a jolt, and it deploys your airbag, saving your head from breaking apart. Those MEMS devices are in your cell phones. When you move your cell phone, you rotate it from portrait mode to landscape mode. How do you think it recognizes it? There's a gyroscope in there and an accelerometer in there. That's what recognizes it. There are lasers, there are LEDs. All these are done not by silicon, but by compound semiconductors. And I'll tell you a little bit about my the value that I bring and my experience in compound semiconductor technology and what I can do. And that's why I'm looking to be able to bring that technology to India. And of course, I'm going to be gated by the United States. I'm a US citizen. And so there has to be some political wheeler dealing as well to allow me to transfer the technology to India. So let's go to the next slide. As I said, there are a number of corporations that can help transfer the technology, but Government of India negotiations are needed to facilitate this technology transfer from the US, from Canada, from Japan, the Netherlands, from Germany, from Taiwan, various places. So Antardhvani is twofold. One is the medical device company. The other is the MEMS sensor company. But that MEMS sensor company is also very capable of being repurposed to build all those other devices which I mentioned for RF, for power, for telecommunications, for optoelectronics, all those. So it can be a pure play foundry as well. So I'm proposing to build two companies. One is a compound semiconductor fabrication company, and the other is a medical device company. And as we all know, India is suffering from extremely poor healthcare. If the United States is suffering from healthcare issues, what must India be going through? And I know that very well. So enough about all that. One small example that I thought that I'll show the students before I wind up is a craft demonstration of something that I did at Global Foundries, and that'll bring to you, to your attention, what kinds of skills it takes to do something radically transformative. And I'll close with that. So there's a lot of noise going on in the background. Can people mute themselves, please? Thank you. So when I was at Global Foundries a few years ago, the situation was that Global Foundries was competing with TSMC. And as I mentioned, TSMC is the market leader. It owns about 35% of the semiconductor market. And GF sales were cratering. My task was to go fix that. I was supposed to go in and fix design services, but knowing what I knew, I built out IP, design services, aka design solutions, to fix this, because companies came to Global Foundries or any other semiconductor manufacturing company for a solution, not just for silicon wafers. They needed to be able to design in that process technology node. And for that, you needed intellectual property. You needed skills. You needed technology. And so I built all that out. I canvassed and built an IP council, as I mentioned under the actions category here. This is a classical way of describing anything: situation, task, actions, and results. It's called behavioral interviewing. I put it in this way so that it becomes very clear to people. So I built out the IP council. I led strategic planning. I figured out what the markets that we were playing in needed, who the key customers were. You have to be customer focused and you have to work back from customers. And so you figure out what their roadmaps are and you align yourself with those short-term and long-term roadmaps, and then you execute. You build out all that infrastructure. And so I wound up leading the technical pre-sales. As a result, I built a business unit well over $1 billion in less than a year and a half. And so that's all I wanted to say as an example to people in your esteemed engineering college, that there are things that can be done, my friend. There are a lot of things that can be done. You have to have those qualities that I described earlier: the character, the competence, the judgment, the attitude, and the hard work. Yogaha karmasu kaushalam, the skill to be able to do it. I close with that same shlok of the Bhagavad Gita. Yogaha karmasu kaushalam. Yoga is skill in action. Thank you for listening to me. I'm done, Abhinashi.
Thank you so much, sir. Thank you so much, sir, for your valuable presentation. Thank you, sir.
You're welcome. You're very welcome.
Any questions from the respected audience?
This is one thing I find very curious amongst Indian audiences. And I've spoken to many Indian audiences. In 2010, when I came to India and I was given an offer of a faculty position, both by IIT and by BITS Pilani, nobody asks questions.
One question.
Thank you. Thank you.
Regarding data converters, you have used AD, A by D, B by A.
Sir, would you please identify yourself?
My name is Dr. C. Manikumar. Sir. Manikumar.
Thank you.
So I have one question in your block diagram. Data converters. You have used A by D and D by A converters.
Yes.
How much is its data type resolution? How many bits data type converter?
It's typically about 12 bits of resolution and 40 to 80 megasamples per second sample rate.
40 to 80 megasamples.
Yes.
With just 12-bit data.
Just 12 bit. That's good enough.
Okay. So now
but
we are having
the key, Dr. Manikumar, is the power. When you want to miniaturize it, it's the power that kills you.
Okay.
So you have to be able to get these circuits to work at sub 1 volt operation. And they have to work in the technology nodes where the digital logic is working, because they have to be integrated into the same chip.
Yeah.
They cannot be distinct chips. Right now, they're using distinct chips. And that's what leads to the cost. That's what leads to the power. That's what leads to the area. And that's why you have an expensive, large system.
Yeah, chip design.
I actually co-invented the world's lowest energy per conversion IQ ADC. IQ means, you know what IQ means, right?
Yeah.
IQ ADC,
yes,
is inline and quadrature. The lowest energy per conversion in the world in 2009, and that continued into 2015. So that's why I embarked upon this journey. That actually led me to Antardhvani. Go ahead, please, Dr. Manikumar.
Yes, sir. Yes, sir. Thank you. Thank you very much. Thank you.
You're very welcome.
Thank you, sir. Any more questions from the respected audience?
I would really like to see some of the students from this university do some great things. it's not just the IITs that can produce great things. Don't be under that illusion. The trouble is that everybody in India, and I know I'm casting a big net here, so please pardon me if I'm hurting any sentiments. Everybody in India wants to get rich quick. So they want to do software. They want to do an MBA. They want to come to the US. Crap. Go do something hard. Go do something really game-changing. And you all can do it. You're intelligent people. You need to reach out to people from whom you can gain the knowledge, or heck with it, go get the knowledge yourself. I had nobody teaching me. In all my years at Pilani, as I mentioned, I spent my time reading the Upanishads, and I still graduated second in my class. So you can do it. Go and do something and give back to the world. You've been fortunate enough to get a lot from the Lord, from Mahadev. So go and do something and change the world.
Beautiful.
God bless you.
Beautiful.
Thank you.
Thank you so much, sir. Thank you.
Thank you.
There is a small announcement for the participants. There will be a 10 minutes of break, and after that, within 10 minutes, we'll be joining our technical sessions, starting with the technical sessions. Thank you.
Hello, Abhinash. Hello.
Yes, ma'am.
Yeah, Dia.
Yes.
Dia, am I audible clearly?
Yes, ma'am.
Can I know, there are two sessions parallelly going on. So there are
yes,
two
ma'am.
different links for each, or how we could join our own group?
Ma'am, breakout rooms will be created soon, within 5
Okay.
minutes.
That is not yet created, no? Okay, thank you.
No, not yet. There is a small announcement for the participants. Breakout rooms are created and participants can start joining the breakout rooms. Thank you. There is a small announcement for the participants. Technical session 2A is for the mechanical students. Technical session 2B is for the CSE and IT and ECE and Triple E students. Technical session 2C is for civil and SNH. Thank you.
Hello. Hello. Can we start? Hello. Hello. Hello.
Yes, sir. Yes, sir. Yes, sir.
Ma'am, do I start my presentation now?
So just a minute. So just a minute, please.
Okay.
Yeah. Thank you so much, sir.
Hello.
Yes, sir.
Can we start, madam?
Yes, sir. We can start.
Power sir is there, but he had joined the session, but he cannot ask the question. He is currently right now in meeting.
Okay. Joshi sir, we can start the lecture. Sorry, presentations.
Okay, okay.
Yeah.
Let me introduce session chair, Dr. Pawar sir. Dr. Pawar is currently designated as Register and Associate Professor at Sarvapalli Radhakrishnan University, Bhopal. He had joined RKDF Institute, Science and Technology, Bhopal in 1997 in Mechanical Engineering Department. And he has completed BE in Government College of Engineering, MP. He also completed MTech from MANIT, Bhopal, and PhD from RGPB University, MP. He has reviewed a numerous papers and has also made various published researcher of his own several national and international journals. He also recognized has amazing teaching skills. He also supervised various PhD scholars during his academic career, and he also guided the 100 of students and has completed MTech successfully. He also has been guest lecturer at various important events. So this is an introduction of Pawar sir. Madam, can we start presentation?
Yes, sir. Yes, sir. Thank you so much, sir.
Okay.
I'd like to welcome our first presenter, Neha Satish Kildar ma'am, for a presentation on title Design and Analysis of Composite Driveshaft.
Yes,
Neha,
ma'am.
ma'am?
Yes, ma'am. Present here.
Yeah, okay.
Is my screen visible, ma'am?
Yes, ma'am, your screen is visible.
Yeah. First of all, I will introduce myself. My name is Neha Satish Killedhar. I am a MTech's mechanical design student from RIT Islampur, and currently I am working with my guide, Professor Dr. S.S. Gowde sir. And topic for my today's presentation is design and analysis of composite drive shaft. In this, all of us know that drive shaft or propeller shaft is used by considering the following purpose in vehicle, mostly as a torque transmission and rotation of the vehicle parts. And composite material is defined as the material composed of two or more constituents combined on a microscopic scale by mechanical or chemical bonds due to their low specific gravities and better strength to weight ratio. And these composite materials have superior to those of metallic materials. So this is the abstract for my work I have prepared. I will go through it. An automotive drive shaft is the most of the important component to torque transmitting, which is subjected to high torsional and shear stresses. Composite material drive shaft has a more strength to weight ratio, high corrosion resistance, and wear resistance as that of conventional drive shaft. In this work, the study of conventional and composite material drive shaft is done. The finite element analysis using ANSYS in that static analysis and ANSYS composite prepost, which is known as SCP, mostly performed on the composite materials, is done on the both of the shafts with the conventional and composite drive shaft, in which composite drive shaft was consist of 3 layers of aluminum and 2 layers of glass fiber. That is designed by using torsional buckling equations. So as a result, the composite drive shaft withstands with less deformation and less distribution over each layer, with maximum torque of Maruti Omni is given. Also, with a higher strain to weight ratio, it also optimizes the weight of the shaft and the vehicle also. So it is beneficial to use the composite drive shaft rather than using conventional mild steel drive shaft. This is the literature gap I had carried out after the literature survey. That previous work on composite drive shaft has been done using materials as glass fiber and carbon fiber, but there is very less work done in composite drive shaft using material as glass fiber and aluminum together in the orientation of 45 degrees. So this is the necessity of work because composite materials have following properties as a higher specific stiffness, strength specific modulus, corrosion resistance, wear resistance, fatigue life, and lightweight properties higher than the conventional mild steel material. So making use of those composite materials in drive shaft is beneficial than use of conventional mild steel material. So this is the problem statement I have derived from the survey of the literature as use of mild steel drive shaft causes to increase the weight in drive shaft. Also after application of maximum torque condition, it gets more deformed and gets high torsional stresses into it. So to avoid these losses, it is necessary to get introduced to composite materials which can withstand to higher torque conditions and also gets less deformed and less stresses induced in it. Also, it can reduce the weight of the drive shaft, consequently the weight of the vehicle, and it also increases the efficiency of that vehicle also. So these objectives are derived from the problem statement as to design hybrid composite one-piece drive shaft as a replacement of conventional mild steel drive shaft. To simulate and compare the performance of conventional steel and hybrid composite drive shaft using finite element analysis, to design the a hybrid composite drive shaft for the optimization of the weight of that shaft. So first of all, modeling is done for the conventional drive shaft, which is considered as a Maruti Omni's drive shaft, which has a higher torque, 59700 Newton mm. After consideration of a factor of safety, it becomes 73750 Newton mm. All the analysis done by considering that torque only. The modeling of hollow drive shaft of Maruti Omni car is done as shown in figure, which is done by using CATIA V5 R21 version of CAD software, which has various geometric features and tools. And for the design of composite drive shaft, the torsional buckling is considered, as I said previously. For the each layer, as I said, 5 layers are there for a composite drive shaft, 3 layers of aluminum and 2 layers of the glass fiber. As a glass fiber is composite material, it has orthotropic material properties for each direction. It has different properties, such as it has different Young's modulus for different directions. So by considering those properties and these formulas, I calculated exact safe diameters and length for the composite drive shaft. And I modeled this drive shaft according to those dimensions, such as inner diameter for it as 18 mm and outer diameter it for as 28 mm with 400 mm length. This modeling is done by considering the availability of testing setup So after performance of analysis, this results has been drawn as this shows the analysis done on the hollow mild steel drive shaft. The one end of the drive shaft is fixed as considering the boundary conditions, and at the other end, maximum engine torque of Maruti Omni car after consideration of factor of safety, which becomes 73750 Newton mm, given on the another end of the drive shaft. This is done for the analyzing total deformation for specific torque and von Mises stresses. While doing the analysis, density of the material is kept as it is as 7840 kg per meter cube. And weight of the conventional mild steel drive shaft is drawn from the analysis is 5 kg. So here we can see the results as a equivalent stress of for the torque of 73750 Newton mm becomes 65.163 MPa, and the total deformation for the torque of 73750 Newton mm it becomes 0.19325 mm. For the analysis of a composite drive shaft, ANSYS pre-post composite is used. This shows the analysis done on the composite material. Here, for the analysis of composite drive shaft, 3 layers of aluminum and 2 layers of glass fiber are added one by one. The one end of the drive shaft is fixed like mild steel, and at another end, maximum engine torque is given. So this is done for the analyzing of the total deformation for the specific torque and von Mises stresses. So the following properties are kept while analyzing composite drive shaft. For the density of the glass fiber is kept as a 0.00244 kg per meter cube, and after the analyzing of composite composite drive shaft, the weight becomes 2.67 kg. So this is the analysis done in the ANSYS composite pre-post model. This calculates the stresses for each layer. So I calculated those results from the ANSYS for top layer and bottom layer. We can see here equivalent stresses we can get are 1.4437 for top layer, and for bottom layer 2.6174, and if we go for the total deformation, we will get it as 0.030132 mm. So these are the results for mild steel drive shaft, and these are the results from for composite drive shaft. So we can see here there is so much difference in the equivalent stresses we got from for the mild steel drive shaft and equivalent stresses for composite drive shaft, and same for the total deformation. We can see after comparing those results, we can get the following conclusion as strain to weight ratio of the composite drive shaft gets higher than that of conventional mild steel drive shaft. Stresses distribution of hollow mild steel drive shaft in ANSYS is more than distribution in the hollow composite drive shaft using ANSYS composite pre-post, which shows the composite hollow drive shaft with material of aluminum and glass fiber can withstand to the same torque with less deformation and less stresses than that of the conventional hollow mild steel drive shaft. And validation of those results, there is a scope for validation of those results by doing experimental work using torsional testing machine. And these are the references I have gone through while working on that work. So it is done. Thank you for all.
Thank you, ma'am. Any questions from the respected judges and the audience?
Hello.
Any questions? Yeah.
Yes, sir.
I think you used a carbon fiber as a composite material, carbon fiber and
No, sir.
aluminum.
Aluminum and glass fiber I used.
Okay. So why only glass fiber is used? Why not other material?
Actually, when I gone through the research papers, and there are work done in the aluminum and carbon fiber. So that somewhere mentioned that there is also scope for using glass fiber. So I gone through it and go for the results for glass fiber only.
Okay, and I think you did the testing torsional resisting, correct?
No, I said that there is only scope to do that. I didn't did anything.
Okay.
Yeah.
And you did the analysis in ANSYS software, correct?
Yes.
So how will you do the analysis of composite material in ANSYS?
In ANSYS, we can do analysis for composite material by using composite prepost, ANSYS composite prepost, in
Okay.
which laminates are used of the specific thicknesses, as a lamina means a single layer in which layers are stacked in specific orientation. That orientation I used as a 45 degrees, and for all layers it is not possible to calculate the stresses and deformation, so I calculate only for top layer and bottom layer, and deformation for overall shaft.
Okay. And which types of loads are acting on drive shafts? And have you calculated on same on ANSYS?
Actually, on ANSYS only I calculated equivalent stresses, angular deflection also, and total deformation only.
Okay.
Yeah.
And it is used in Maruti vehicle.
Yeah, Maruti Omni specifically.
Okay. So before it is mild steel, correct?
Yes,
And after it is glass fiber and aluminum.
aluminum.
So what is the cost difference between these two shafts?
Actually, a cost difference, exactly I didn't calculate it, but there is a difference nearly about 40 to 50% increase for the composite materials. So it
Okay.
is costly than mild steel.
Okay. This is for one manufacturing of one shaft, correct?
Yes.
So if we go for the mass production, what will be how it is affect on a cost?
It will mostly affect on the cost, because cost of composite material is higher than other conventional materials, but we can use it because of its properties, as its strength, wear resistance, and corrosion resistance, and also because of its lightweight properties, it can be affordable to anyone.
Okay. And what is your opinion on point of your product life?
Product life is also increases due to its properties.
Okay.
Yeah.
Okay. Thank you.
Yeah. Thank you. Any other questions?
For the report. Any more questions? Joshi sir, can we move to the next participant?
Yes.
Thank you, sir. I would like to invite Praveen Sarode sir for presentation on evaluation frontal crash test of developed vehicle cases frame structure to identify crash worthiness through scaled model for injury reduction. Praveen sir, are you present here?
Yes, ma'am. Am I
Yeah.
audible to all?
Yeah. You're audible to all, sir.
So I'm sharing my slides. Are you able to see it now?
Yeah. It started sharing.
Okay. So good afternoon, everyone. I am Professor Praveen Sarode from ICETET Institute of Technology, Shirpur. And my topic of research is relevant to the vehicle crash systems. I'm doing my work under the guidance of Dr. Sanjeev Surunshi sir, head of the department, SSFS Engineering College, Dhule. And my topic is evaluating frontal crash tests of developed vehicle chassis frame structure to identify crossworthiness through scale model for injury reductions. Now, one topic is relevant with the crash analysis of vehicles actually. And moving to the next slide. So the outline of my presentation is like this: introduction, literature review, problem statement, methodology, result discussion, and conclusion references. Now, what is happening actually means my topic was relevant with the accidents and how we can, what happens during the accidents and how we can reduce these accidents. This is a very important topic. And in throughout, means it's a very serious problem throughout in India and throughout the world actually. Most of the deaths happens due to these accidents. And if quantitative research, if you study, then we can see that as per the World Health Organizations, most of the deaths happens in India are due to the accidents. And it's part of 6 of complete deaths in India. It is quite impossible actually or difficult to develop safety solutions for all these vehicles. Most of the vehicles companies and manufacturing companies are trying to their best to develop these passive and active safety system to implement into the vehicles, but it is quite complicated till today. And that is why one of the solutions we are proposing is that to develop a vehicle chassis frame in such a way that it will reduce the impulse of that accident, that impact, and it will ultimately reduce the magnitude of that acceleration pulse. Now I will let you explain what is actually all these terms, and then you will come to know that what happens during the accidents and how casualties happens. This is the literature review. I have put some of the important literature papers here to identify the main cause of accidents and their what is the right now status of accident scenario in India and as well on the world. Now, if you just go through the statistics of road accidents in India, by just observing the pie chart, and you will come to know that what is the scenario of accidents. If you see carefully, the most of the the graph indicates percentage of deaths due to the accidents. These are the NHRC reports of 2017 and 2019 for comparative. And you will see that the age group of deaths is from 19 to 35, and maximum deaths occurs due to between these age groups actually. And this is very, very crucial. This is particularly statistics of Indian region only. So more than 50%, near about more than 50% people were dying in this age group, and this is a very productive age group. And we should be very much cautious and very much careful that how we can reduce this. 2017, this is the percentage of deaths of this age group, whereas in 2019, this is the percentage of age group. Now, we are more conscious how we can reduce this, and this is why. And let me tell you what is happening during the accidents, and then I'm going to explain you what kind of measures we are proposing to reduce these casualties due to this impact. Now, if you see the image animation, you will come to know that what is happening during the accidents. Suddenly, when accident happens, suddenly the vehicle stops with a very high amplitude of acceleration at this particular moment that we call a jerk. And that impulse of that acceleration pulse was so high that the person seated inside the vehicle is not able to cope up with that acceleration momentum, and it will try to move in a forward direction, and it will get impacted over the steering, over the windshield, and that impact was so high that it will cause casualties. It will create such a high injury to the human being that it will not able to sustain. So what is actually happened, summarize, if I want to summarize this process, if the shorter time of acceleration pulse is, if the pulse time was so small, then the impact of that acceleration was so high. If you could able to increase, or if you could able to prolong the crash pulse, there could be a possibility that we could able to reduce the impact of that pulse. This was the logic behind our innovation. So now what I am going to show you, that what kind of frame, what kind of chassis frame we are proposing. This is our proposal, and this vehicle chassis has already been patented for, has been drawn for 4 patents. What we are proposing, or basic frame, we are putting a sliding frame there. The base frame is responsible to carry the weight of the engines and main body, and whereas the sliding frame, or which will be responsible to carry the weight of the sitting beds actually. Now, this is the front end, this is the rear end. Now, when the impact will come to the vehicle, what we are using actually, we are using utilizing the energy of impact to reduce the value of impulse. So in this case, what will happen if the impact come over the sliding frame? It will ultimately push that seats of occupants with the large with the distance away from that steering wheel and the static elements of dashboards. So ultimately, what we are trying actually, we are increasing the distance between the drivers or the occupants from that steering wheel. And ultimately, what is happening actually during the accidents, due to the momentum, the occupants, the drivers were coming over that steering due to the momentum, and that impulse and that force of impact was so high, and that the injury creates a very high impact, and that's what death occurs. But we are trying to increase the distance. Ultimately, it will not able to impact over each other. This is our main intentions. This is our proposed chassis frame, and we have done experimentation over it. And what we observe, and generally this kind of test will be done in an area where crash analysis has been done. But these crash tests are so expensive that you can't able to do it actually. One crash test costs near about 12 lakhs. So what we did actually, we use a pendulum to create that kind of impact into the experimental, into the laboratory. And we did our analysis, experimental analysis into the laboratory. And there are certain limitations that we have actually, but still we completed our experimentation, and we observed a very great results here actually. We identified the momentum velocities of these impacts using the momentum equation, and we found the impulse graphs over it after continuous number of readings. And we see that if you see the impulse of pendulum, if you see the blue line into the graph, it will show that these are the ratings of impulse pulse. And if you see the slider, this is the slide, orange color line indicates the slider pulse, over which the seats were mounted, over which the drivers or occupants were sitting. So you will see that it was very, very less compared to that pendulum impulse. And if you observe the graph of acceleration pulse in both of these cases, you will see that acceleration pulse of slider frame was so minimum that it will not able to hamper anyway to the driver, though there is an accident. So these are the results that we observe, and this is the energy loss due to our system, how much energy it is going to absorb due to that sliding frame that we are mentioning here. The blue color indicates in this graphs was a loss of energy, whereas in initial cases, this much energy was been used to crush to the frontal members of that vehicle, but still that energy was so high that people were not able to sustain that impulse, and that's why casualty happens. So we are trying to eliminate this much energy, we are absorbing this much energy. That's why the acceleration was pulse of that accident was so less, and this is our achievement. Over it, at the end of that sliding frame, we are putting a solid damper. This is a kind of design that we are putting there into the solid damper, and it will work like this. So at the end also, if no matter what impact of the crash is actually, that sliding frame is also not moving with that that speed. It will reduce up to a certain large extent. It will take a large extent of time to damp that oscillation, that impact, and the solid damper will put take a very large impact, so that it will also not create an impact due to that. It will also not increase the pulse of accident after the accident also. So these are our achievements. And if you say the conclusion, what conclusion we will come up with this vehicle or structure, that with the increase of time, the developed models show the significant reduction in crash pulse. And this will help to reduce the severity of injury in the event of accident. This is our main achievement. And ultimately, the magnitude of acceleration pulse obtained from the sliding frame is very small. And ultimately, it will help to reduce the crash pulse during the crash. So what is expected, that if we could able to reduce the pulse of acceleration by improving or by prolonging the time of accident, definitely it will not create a very serious injuries to the occupants, and we can save the life of occupants in this way. So this is our work right now, and we have filed 4 patents over it also. These are the references, and thank you very much for your kind attention. Anything you want to ask me?
Any question from the respected judge?
Hello.
Yes.
Sir. How can you measure the impact on driver side after fitting that sliding frame on chassis?
We did experimental work, and whatever calculations we did is our analytical calculations. By using the momentum of inertia, principle of momentum of inertia, we identified the what kind of acceleration it is getting after the impacts, and then we calculated it by using the analytical methods, and then we also did a analysis also. But right now we have not mentioned here actually. There are.
Okay. And which type of analysis you did in ANSYS?
LS Dyna we use for crash analysis.
Okay. Okay, thank you.
Thank you very much.
Hello, am I audible?
Yes, ma'am.
Yeah, any more questions? So shall we move to the next presenter?
Yes.
Yeah, thank you, sir. I would
Thank
like
you.
to invite Sunil
Thank you very
Kumar
much.
Arsu, sir, for presentation on a review on machining of polymer composite reinforced with natural fiber. Sunil Kumar, sir, are you present there? Sunil Kumar, sir? Sir, can we move to the next presenter with your permission? We would like to call Kunal Shighaukar, sir, for presentation on design analysis and AMP, weight optimization of lift panel using composite material. Kunal, sir?
Yes, Kunal. Yeah, I'll share my screen.
Yeah, okay, sir.
Yeah, is my screen visible?
Yes, sir, your screen is visible.
Yeah, I'll start. Yeah. Good afternoon, everyone. So the topic for my topic is the design analysis and weight optimization of lift panel using composite material. I'm completing this project under my guide, Dr. S.S. Gowde. So for a short introduction of myself, my name is Kunal Mahendra Shegokar. Currently, I'm studying at Rajaram Bapu Institute of Technology, Islampur, and currently I am doing MTech in mechanical design engineering. So I'll move forward. So for this project, the main aim of this project is let's take the what conventional lift we are using. So the conventional lift used in industries, they are actually used for lifting equipments, material, and when these material and equipments are lifted, so its initial weight of the lift, itself it is more. So to overcome this initial self weight of the lift, the power requirement is also more. So while overcoming this self weight, the power consumed is actually higher. So so for that, this project is actually I've taken this project. So this is the abstract for the project. So the abstract, it says that the conventional lift used in industries, they are actually bulky and heavy. So considering the weight factor, due to the self weight, the power is consumed consumed it higher. So instead of using the homogeneous metallic structure, an alternative, which is composite sandwich structure, it is used. So the main advantage of composite, using the composite, is it is having good strength and low weight, and using its combination is comparably better than using the metallic structure. So due to its advantages of high strength to weight ratio, this project was designed. So this paper will discuss the use of composite material at the core or the cross section, which is then sandwiched between the panels so that efficient structure can be prepared. So this structure is analyzed in ANSYS for deformation and stresses. The structure is tested for compressive strength, which is then compared to the conventional lift for strength and weight. Overall, the weight reduction of lift is ultimately reduce the power consumption is the main purpose of this paper. So the necessity of work, as I already told, the need for a lightweight structure in industry in case of lifting, and this can be achieved using the sandwich structure design. Though again, it has high strength to weight ratio. Moving forward, so this is the you can see the sandwich composite structure which I was earlier talking. So the main advantage of using the sandwich composite structure is it has high load bearing capacity. Also, it is advantageous in thermal insulation. It has long life and low maintenance, and it has low due to use of composite. It has low overall density, excellent acoustic damping properties, high strength to weight ratio, and high stiffness to weight ratio. So currently, the sandwich structure, it is used in planes. As we know that the requirement of the main requirement of planes is having the low weight so that it can fly easily. So similarly, below you can see a different type of cross section or sandwich which is done between the plates. On the top right, here you can see this is the blade for helicopter where the sandwich structure is used. Moving forward, so from all the this discussion, I have from the literature survey, I have concluded the problem statement. That is use of composite structure in sandwich corrugated structure to minimize the weight, and design development, analysis, and formulation for strength and development of solution to improve the behavior. So for going forward to the analysis, so for analysis, for the sandwich structure, the ASTM has given a standard, which is ASTM C393 for sandwich structure. Using this ASTM standard, I have designed the specimen used for the analysis. So the ASTM standard says that the length should be equal to the span length plus 25 mm on each side should be given, which is equal to 50 mm. So total length is 200 mm, and the width should not be less than twice the total thickness. Then the thickness is kept according to the actual lift thickness. So the dimension obtained from the ASTM standard is length is 200 mm, width is 50 mm, and the thickness is 25 mm. So using this dimensions obtained from this ASTM standard, so this 3D model 3D model is created. It is created using the SolidWorks software. Here you can see that there is the top plate and bottom plate, and in between the cross section, circular cross section and rectangle cross section is there. So this using this cross section, sandwich structure was created. So as boundary condition, so for for analysis in ANSYS, this specimen was imported in ANSYS, and according to the ASTM standard, the support was provided at 25 mm distance from each end, from left and right end, and the load was applied at the center. So the maximum load which was used is 15,000 Newton. Moving forward, so the analysis is done for circular cross section and the circular cross section. This is total deformation and equivalent stress, and similarly for rectangular section and equivalent stress for the cross section was obtained. So this is the result for the rectangle cross section. Here you can see that it is highlighted in the red. So sorry, so 15,000 Newton load, the obtained stress, maximum equivalent stress is the 356.6 MPa, and the according to deformation is 0.44 into 10⁻³ mm. Further, the result for circular cross section is for 15,000 Newton is 148.43 MPa, and the obtained deformation is 0.0969 into 10⁻² mm. So this is the comparison of the result for load versus stress and load versus deformation. Here you can see that the rectangle cross section given in blue, this is having the higher stresses, and similarly in deformation is high, whereas the circular cross section has low stresses and low deformation. So according to that, the conclusion was derived that the circular cross section is more advantageous, and it can be used in the conventional lift. So using that circular cross section in the conventional lift in the cross section, bottom cross section, the further analysis was done. So this is the analysis for conventional lift, where the maximum stress obtained was 28.159 megapascal, and the maximum deformation is 0.86 into 10⁻³ mm. So as I was earlier saying, this circular cross section which was finalized, it is used in the conventional lift in the bottom cross section, and observed maximum equivalent stress is 18.095 MPa, and the maximum deformation is 0.237 into 10⁻³ mm. So getting the overall conclusion, so the maximum stress for the cross section is rectangle cross section is 356 MPa, and minimum is 148 MPa, and minimum stress is 148 MPa in circular cross section. And similarly, deformation, observed deformation is more for rectangle cross section, and minimum for circular cross section. So as it was, I have already said the circular cross section was prominent than rectangular cross section. And on comparing the result and deformation in conventional lift and the lift with circular cross section, the obtained stresses and deformation is less for the circular cross section. So it is more prominent. And using the circular cross section, the overall weight of the lift was also reduced. Earlier, the overall weight of the lift was 340 kgs, which was reduced to 276.56 kg, which is almost a reduction of 64 kgs. So as this was the main aim of the project, to reduce the overall weight of the lift structure using composite, it was achieved. Thank you. So if anyone have any question, they can ask.
Thank you so much, sir. Any question from the respected judge?
Hello, Kunal.
Yes, sir.
You're Kunal Shegokar, I suppose.
Correct, sir. Correct, sir.
Yeah. Can you tell me, have you completed this project? Have you manufactured the lift?
So no, sir. Going further, I will manufacture it. I will not manufacture the total lift, only the specimen which I have earlier shown. I'll show it again. So this specimen, this specimen will be manufactured. It is of 200 by 50 by 25 mm, and this will be tested using 3-point bending test, which is the ASTM standards for sandwich construction. It says that using this 3-point bending test, the results can be obtained.
But you are saying design, analysis, weight optimization of lift panel.
Yeah.
So while designing, what were the conditions like? How many this lift is meant for goods carrier, or it will be meant for people transport?
It will be meant for goods carrier.
Okay, so what was the weight that you have assumed while design?
So, sir, the initial weight was 300 kgs. Its lift weight was.
That is the maximum capacity?
No, its lift self weight was 300 kg. Maximum capacity is 15,000 Newton.
So for that purpose, you are optimizing this using composite or reinforced material.
Correct, sir.
Okay. But you are just providing the results using the software, isn't it?
Yes, sir.
So the software results can be easily manipulated, the ANSYS results.
Sir, I further I will be manufacturing and using the ASTM standard. It can be proved that the results obtained can be, or if further it is not, the results are not according to the requirement, the changes can be made.
Yeah, this was your BE project?
No, sir.
Then?
MTech project.
MTech project.
Yes, sir.
So for MTech level, that is what I wished. Simply using the software, because it needs to be validated.
Yes, sir. It will be validated, sir.
How?
Sir, this using the here you can see, sir. Is my screen visible right now?
Yes, yes.
Yeah,
I understand. You will be making the samples as per the standard. That is fine.
Yes.
But the composite material that you will be using,
yes, sir,
that should be manufactured as per the sample, and that needs to be tested. So what you are recommending? It is which type of composite reinforcement?
Sorry if I have not mentioned, but I'm using carbon fiber here.
Yeah. So that needs to be tested. What will be the combination? How the composite? What will be the percentage like in reinforcement?
Okay.
And manufacturing aspects also, there are so many aspects you need to take care while manufacturing and working on composite materials.
Correct, sir.
So what are those? Have you highlighted? Have you mentioned?
Yeah. So for manufacturing the carbon fiber, it is having orientation of zero degree. Sorry.
Yeah.
Yeah. So using that, at 0 degree, the carbon fiber is taken and it is manufactured using hand layup process.
Which process?
Hand layup.
Have you seen the manufacturing?
Yeah. Yes, sir.
Okay. Do you have any agency who is going to manufacture this?
Yes, sir.
Fine.
So my company itself is I'll manufacture it in my company only.
Which company?
Sir, I'm working at DRDO, Pune.
Okay.
So there it is CRC section is there. So there we
Then it
work
is
on-
fine. If you are at DRDO,
Yes, sir.
then there should be no question of validation. It's okay. Fine.
Yes, sir.
All the best.
Thank you, sir.
Yeah.
Any further questions?
Yeah. Regarding the references, have you mentioned the references?
Sorry, I have not mentioned, but I've done the literature survey and references. So
Okay.
I've not mentioned here. Sorry for that.
It's okay. Fine.
Any more question?
No, it's all from my side. If anybody is having, they can go ahead.
HK is 72. Okay. Thank you so much, sir. Can we move to the next presenter, sir?
Yes, ma'am. Yes, please.
Yes, sir. Yes, sir. I would like to invite Kunal Chaudhary, sir, for presentation on numerical investigation of bio-inspired honeycomb structure in energy absorption for crashworthiness.
Yes, hello.
Yes, sir.
Yeah.
मुझे तो पता ही नहीं है ना दीदी
Hello, my name is Kunal Chaudhary from MIT EDT University, and along with my author and guide, Professor Dr. Archana Nema has guided me in this project of numerical investigation of bio-inspired honeycomb structure in energy absorption for crashworthiness. So accordingly, the problem statement for this project is to experimentally and numerically investigate and study the bio-inspired honeycomb structure in energy absorption for crashworthiness. And objectives that I will encounter in this project is that identification of problem statement and developing a sample design for crash absorber, numerical investigation and testing of the model, analyzing the results, and testing and comparison of the convention of the honeycomb inspired energy absorber with the conventional absorber. So beginning with the abstract. So abstract for this project is to ensure safety during collision. So the impact energy must be orderly absorbed or completely dissipated. So this is the main aim. Accordingly, the biomimetics, that is engineering inspired from biology, that is the center idea on the basis of the project. So there is the baseline of the project says that there is no model better than nature to develop something. So here the structural integrity of the honeycomb is encountered. So in the same way, the field of crash safety, in order to avoid the frontal impact and crash absorbing element is essential, such as crash box. So in this project, geometry of suitable cross section is designed in CATIA, and accordingly the design and energy absorption, force displacement and force impact resistance simulation was done in ANSYS. So then a prototype of an aluminum honeycomb absorber, energy absorber, was fabricated and accordingly tested for the force acceptance and impact testing under specific load. So the specific energy absorption characteristics will be studied, and accordingly the comparison between the conventional absorber and the honeycomb absorber will be done. So it is basically related to crash safety, biomimetics, aluminum honeycomb, impact test, ANSYS, deformation and energy absorption characteristics. So description includes energy absorbers are more important in crash analysis. So shock absorbers come in a variety of shapes, sizes including springs, solar panels, crash cages, etc. To some extent, vehicle tires also act as the absorbers, shock absorbers. So however, in terms of energy absorbers, they are mainly utilized in automobiles for the purpose of crash safety. So the bumpers are effective energy absorbers in mild collisions, but they must be replaced once they are damaged. So the major purpose of the crash analysis is to verify the vehicle's passenger seats are safe as much as possible. So as a result, the energy absorber is vital for the passenger's overall safety in the vehicle during the crash. So during crash testing, a dummy model, which is a replica of occupant of the car, is used in certain research. So they act like a human-like personality, in which the models are tested along with the crash impact and frontal collisions. So the materials, including aluminum alloys, steel, etc., are used in the crash safety, which can help in improving the energy absorber's efficiency, suitability for the applications. So the crash safety is less important in low-end vehicles. So therefore, a crash absorber is required to absorb the impact during the frontal crashes or collisions. So honeycomb structure is a bionic model with a great rigidity and its geometry. So including a crash safety can lead to novel outcomes. So frontal collisions can be observed to some extent if we use a honeycomb geometry structure and its rigidity characteristics for developing a crash absorber. So accordingly, the design of the model was done. The software for the design was used as CATIA software. Accordingly, the parameters were selected. For designing of the honeycomb was done using computer-aided design software, and the parameters include cell height, cell width, that is 3.5 mm. Accordingly, cell angle was 60 degrees, and the honeycombs were placed in such a way that the L direction, that is the length direction, thickness direction, and the width directions were taken into consideration of the crash. So accordingly, the density, the modulus of elasticity, Poisson's ratio, yield strength were selected for the model. And here we can see the 3D view of the geometry as shown in the figure, that is in the XY plane. Different planes are used to draw these panels accordingly. So the top view of the honeycomb and the side view of the honeycomb core can be seen with the rigid impactor. The rigid impactor is the simulation of the frontal crash that will happen when the vehicle will collide with another body. So accordingly, the rigid impact sphere is taken of radius 8 mm, and accordingly, one panel is supported at the bottom of the core, and the honeycomb is attached over it. So this will form a honeycomb crash box, which will be mounted on the in the bumper. So accordingly, the simulation in the ANSYS was done in order to understand and visualize the mechanical properties like compression, bending of the honeycomb core under impact. A commercial finite element software, that is ANSYS Workbench, was used to study the impact energy on aluminum core. The materials assigned were structural steel for rigid impact sphere, and aluminum alloy for the honeycomb and bottom plate. So according to the boundary conditions and the fixed support, velocity and displacement parameters were given. According to the velocity was given as 50 meters per second in negative global Z direction. Mesh optimization was done. Element order was linear. Accordingly, the mesh quality and target quality was set in this. So the crash box model, energy absorption with the filler of aluminum honeycomb, we got that the result was 2.755 kilojoules was energy absorbed, and accordingly the SEA, that is the specific energy absorption, was 13.77. So the crash box, which is the conventional crash box, that is without honeycomb filler, had a lower amount of energy absorption, that was 1.57 kilojoules, and the specific energy absorption was 7.8. So here we can see how honeycomb is better than the other conventional crash box model as a filler. So here we can see the deformation characteristics of honeycomb core under the impact of rigid sphere, and the elastic strain characteristics of aluminum honeycomb core under the rigid of impact sphere. So accordingly, the testing methodology for the actual sample that will be made will be based on the application of load. So load can be applied in two ways, that is the oblique load and the axial load. So based on the simulation results, it is concluded that an axial loading can give the best results for simulating the frontal collision. So the setup for axial loading is shown will be the impactor, then the crash box and the fixed support, along with the load application mechanism. Then the impactor is same as the impact rigid sphere, will act as same as the impact rigid sphere model in the simulation, as we have seen before. Both the impactor and the fixed support are considered as a rigid body, whereas the crash box is considered to be an elastic body made up of aluminum honeycomb filler. So the main aim of the load application is that the displacement in the crash box should not exceed than its 80% height. So after getting the correct size and the material, the workpieces will be fabricated and the testing for the testing impact resistance. Okay, so impactor has a weight and a load that is according to our convenience, then the impact velocity of 20 to 50 meters per second will be given. According to that, the various loads will be applied and readings will be taken for the deformation to be calculated. The direction of the loading plays a very important role. The displacement characteristics in this can be found for all the three directions of the honeycomb, namely the L direction, that is the length direction, width direction, and T direction. So accordingly, the L direction displacement of the honeycomb will exceed, that is 100%, which will not be beneficial. Hence, it demonstrates that the model will itself demonstrate that honeycomb is unable to absorb energy along the L direction. So along the W direction, it will be same. So it will not be beneficial, as it will not be able to absorb the desired energy. So therefore, the T direction is selected. It is best to apply the load at it is capable to absorb the enough energy during the impact. So accordingly, the force and displacement graph will be plotted based on the readings. Buckling in the T direction will be given. Buckling in the T direction will be analyzed in the sample itself while testing. Okay. So the conclusion is that the energy absorber is a system which converts the kinetic energy into another form of energy. So energy absorber is a passive safety feature which is important to absorb the impact energy and its dissipation to the vehicle body parts. So deformation of aluminum honeycomb is beneficial rather than the conventional crash boxes accordingly. So we can also conclude that the geometry of the honeycomb structure, which was biomimically taken, had proven the best geometry and the analysis of the crash moreover than the load application. Whereas we can also say that the direction of the load applications plays a vital role. So here the SA, that is specific energy absorption of aluminum honeycomb crash box, was found to be more than the conventional one. So the aluminum foam shape was found to be the best filler material for the crash safety to enhance the crash worthiness. So accordingly, the references from these many references were taken for the project. Thank you.
Thank you, sir. Any questions from the respected judges?
Hello.
Yes. Hello, sir.
Pawar sir, have you joined, sir? Hello.
Our sir is joined, but he is current in meeting.
Okay. So, Kunal, it was a good presentation and it is a good idea to go for crash worthiness, energy absorption for crash worthiness. Now, you have mentioned about a rigid impact sphere, is it?
Yes.
So, this you have obtained from research papers about the rigid impact sphere?
Yes, sir. Actually, to start the simulation for such crash safety, my guide, Professor Archana ma'am, told me to begin with the rigid impact sphere. Then we will test. Then we will do with the rigid wall accordingly.
Okay.
Yes.
Now, regarding the variation in the materials, the rigid impact sphere is made of structural steel, you said?
Yes.
And the rest is aluminum alloy.
Yes.
So again, the combination, again, it is referring to various researchers, or is there any standard specification available?
Yes, for aluminum it was available, but for the structural steel, it was a rigid impact sphere. So we got it from various research papers.
Okay. Any standard mentioned for crash worthiness as such?
No, sir. Right now I haven't studied it.
Okay. Now here I have a little doubt. When we talk of impact, it has to do with the toughness of the material, isn't it?
Yes.
And the potential energy and kinetic energy both comes into picture while absorbing.
Yes.
But can you elaborate this concept?
Yes, sir. Sir, actually, it converts the kinetic energy into another form of energy. So we will basically study how the energy is dissipated through the honeycomb structure and the conventional one. That is the main aim, sir.
So converted into which form?
Sir, I need to study that.
Yeah, there only the confusion starts.
Yes, yes.
Exactly. Okay, fine. So you'll be actually testing, preparing the samples and testing the crash worthiness?
Yes, sir. Yes. Aluminum honeycomb sample is ready. I'll be testing it and then validating
And
with the
how
results.
this rigid impact tester sphere is fixed in the
Sir,
structure?
actually, in case of the sphere, the rigid body will be a wall. That is the drop weight testing machine on that. So accordingly, if rigid impact sphere is not available, then we will use the rigid wall as a impacting body.
No, that's fine. But here you have mentioned everything about rigid impact sphere.
Yes, sir. Yes.
So I just wanted to know how this sphere is fitted into the honeycomb structure.
No, sir.
Or
It
you'll
will
be
not.
using the wall only.
Yes, sir. It will be either the rigid ball, that is the whatever the impacting ball we will get, or else we will use the drop weight testing machine that itself has a rigid impacting body over it.
Okay.
So we just have to have the attach the loads over it, and then we will impact it.
Yeah, and here you have shown the figure for axial loading, but when
Yes.
the impact takes place, it might not be axially. It will not be in line. The collision will not be head-on collision, but it will be at certain angle. So
Yes. It will
to
be
take care of such.
yes. To some extent, it will be oblique.
Yeah. So how will this analysis be applicable then in that case?
No, sir. Actually, drop weight testing machine we have fabricated in such a way that it will hold the sample in a axial way only. So it will not allow it to move in a angular direction.
Correct. And the load applied will also be axial only.
Yes. It will be axial only.
Okay. But practically, the situation is totally different from what we are investigating, isn't it?
Yes. It will be different.
So in that case, how you are going to convince about the practical applicability of your study?
Yes, sir. It is actually the advanced part of the project that I'll do later.
Okay. And you're taking help of any agencies?
No, sir, not right now.
Because you might get good inputs from companies like Tata Motors. They are doing the crash worthiness test.
Yes, actually, sir, in functional safety, I have a company with FEV in which they are giving us the functional safety concepts for the project.
Okay, you can talk to ARA people also, Automotive Research Association of India in Pune. This is your MTech project, right?
Yes, MTech.
Fine. The topic is good, but justice needs to be done.
Yes, sir. Yes, I'll look into it. Yeah.
Okay, thank you. This is from my side.
Thank you so much, sir. Any more questions from the respected judges? So shall we move to the next presenter?
Yes, ma'am, please.
Thank you, sir. I would like to call Niranjan Gaikwad, sir, for presentation on numerical investigation on structural integrity of electric vehicle batteries. Niranjan, sir, are you present there?
Yes, ma'am. Am I audible? Hello? Hello, ma'am.
Yes, sir, you're audible.
Okay. Hello, everyone. I'm Niranjan Gaikwad. I'm an MTech student from MIT ADP University, Pune. Here, my guide and co-author are Mr. Professor Dr. Matthew, sir. And my project is on numerical investigation of structural integrity of electric vehicle batteries. Okay, so the abstract that we have seen. So we all know lithium-ion batteries in our which we are using in our day-to-day life for like the common application can be mobile phones, laptop computers, etc. And in recent years, like we have developed electric vehicle batteries, which are lithium-ion powered electric vehicle. So before using that, we have to also see how the lithium-ion battery operates, or what are the different operating conditions, how they can be operated safely. What are the different things that we can do to implement its safety measures. So we are trying to develop here the battery, lithium-ion battery casing, which should have the strength to when the short circuit happens during some other cases or some fire or the crash, it should not penetrate to the cell case so that the lithium-ion battery should not be damaged. So we have done it virtually in the ANSYS software, and we have also used different boundary conditions for that, which we'll be seeing further. So these are my problem statement and objective, that to protect the electric vehicle structurally and also increase its structural strength to protect the battery from creating hazardous situation, and not to have any further damages to the occupant or the electric vehicle. The objective here are to analyze the lithium-ion batteries, which are subjected to high velocity, and what other consequence can happen to the lithium-ion batteries when they are subjected to some load. Second is to investigate the better material to increase the battery strength. Third is the type of different types of tests, and which type we can better implement for the experimental testing further. So like I've mentioned earlier, we have seen the lithium-ion batteries in the vehicle like Tesla or some different vehicles like Nexon vehicle. So government is also encouraging the people to use more and more electric vehicles. So people needs to know that what are the consequences of the battery failure, or how battery can fail, so that they can take better measures to not to have the such bad or fire incident. So according to data from the year 2010 to 2014, there are around 570 fire hazard cases in all overall vehicle, four-wheeler, two-wheeler, we can say. From 2014 to 2017, there are 500 cases, and from 2017 to 19, there are around 390 fire hazard cases. So why the battery fails? So for that purpose, we have developed the casing which can withstand the short circuit or any other damage to them. So here are the consequences of the battery failure. So battery failure are divided into three stages. First is the internal cell failure. Then, so why internal cell failure happens? That's the first cause. When we overcharge the battery, suppose if the battery is at 50%, we immediately put it on the charging. For example, we can take as a phone, our mobile phone. So if the battery is at 50% and we charge it, so the 50% on the gap is covered. So what we need to do, we need to fully discharge the phone battery below 20%, and then we have to charge, because the battery phone company suggests that charging. So if we do this in case of vehicle, so it can lead to battery failure. Then the other consequences can also occur. So what after internal cell failure, the material in the battery it corrodes or it damages due to overcharging. So what happens after that? The temperature rises. When temperature rises, so the separator, we can say the separator between anode and cathode, it dissolves, because it has a very less temperature of melting temperature. So when it dissolves, the lithium combines with its other electrolyte material. So it can then after it can lead to second stage. After second stage, what happens? The pressure and temperature of the battery rises. So of course there are cooling method, different types of cooling method given in that. But what happens if the battery is failed internally? So it can lead to temperature rise. Then safety mechanism are also there to equalize the temperature. So what happens sometimes when there are, suppose for example, you can take 10 cells. So in that 10 cells, 8 cells which are at the state of charge of 20%, and the 2 remaining cells are at the state of charge of 40%. So if we plug in the battery will only cover the 60%. So from 40 to 60%, which is 100% charging will be done. And when we see the batteries, other 8 batteries, it will only cover it will also cover the 60%, but from 20 onwards. So 20 plus 60 is 80%. So that only the 8 cells will have 80% of charge, and the remaining 2 cells will have full 100% of charge. So there's a active mechanism. So it equalizes the temperature and also the state of charge of all the batteries. It will, the remaining 2 batteries will come at 20% of state of charge in that case. So it equalizes all the batteries state of charge, and then from onwards, the charging can be initialized. So other method are that safety design can also cause hazards. If the safety mechanism is not working properly, it can also cause different hazards. So after that, it goes into third stage. So if the initial battery module is not taken care of, it can also propagate the battery fail, or it can also be dangerous to its other adjacent cell. And when it is propagated to other adjacent cell, the overall temperature and pressure of the battery module or whole battery pack is rise, and the fire hazard is initialized. So this is a battery pack model that we have modeled in the software. So we have taken the material in the ANSI analysis software according to the actual material of the lithium ion cell, and the dimensions are all according to the real battery packs. So this is the ANSI analysis of the battery model that we have done. We have calculated equivalent stress and normal stresses on the battery pack. So here we can see the only the high stresses are on the initial side of the battery pack, and it does not propagates to the other end cells of the battery model pack. So this specific material we have chosen as aluminum. So the casing is of aluminum, and we have done the different material, chosen the different material for that. So these are the normal stresses and equivalent stresses for stainless steel batteries, for stainless steel casing. So these are the boundary conditions that we have implemented. We have selected the explicit analysis module for the ANSYS purpose. We have selected the casing material as aluminum and stainless steel casing. The inner material, which is the electrode material, we have considered as lead, and the outer cell casing we have considered it as zinc. So the velocity that we have implemented, which is 10 to 15 meters per second along the x-axis, and we have fixed the lower end so that it should not move it should not move. So this is the testing methodology which we will be implementing. So we will be matching the results of the analysis software and the actual experimental model with the we will validate that result. It is same as the drop weight testing machine. So we will be applying different types of load, and we will be see what are the consequences, or what happens when these types of load are acting on the different casing materials like aluminum and steel. So we come to conclusion that we can get the enhanced battery property battery pack properties of the battery pack for vehicle safety. Then we'll be validating the analysis result along with the experimental result, and we have seen that the steel material has lower deformation as compared to aluminum material casing. So these are the references that I have referred for my project. Thank you.
Any questions from the respected judges?
Yeah. Hello, Niranjan.
Yes, sir. Hello.
Yeah. This is investigation of the battery pack, that is the case or body of the battery, isn't it?
Yes, sir.
Yeah, and the problems associated with the failure of the battery you have mentioned very nicely in 3 stages.
Yes, sir.
Okay. But while investigating, you are just making use of the software, I suppose, the explicit analysis, isn't it?
Yes, sir.
Now, again, my question is, don't you think that the software results can be manipulated?
Yes, sir. That's why we are also doing the experimental results. We will be fabricating the steel and aluminum casing, and then we will be testing it on the drop weight testing machine according to the required weights.
But the problems you have mentioned are quite different, and the test you are conducting, is it going to satisfy, take care of all the problems you have mentioned?
Yes, sir. In the analysis, what we have done, we have tested the battery material. Sorry, the casing we have tested is in the axial direction, and if we see that the battery are placed in the vehicle in axial direction only, so according to that we have tested. We'll be testing experimental result and this analysis.
Yeah, the test which you'll be conducting and you'll be validating.
Yes.
That will take care of which type of problem? Stage 1, stage 2, stage 3.
Actually, it will take the problem of stage 1, sir, because what we have done, we have. Yes, yes.
And what about 2 and 3?
Sir, for that, what happens in stage 2? We are mainly focusing on the damage of the battery. What happens when the internal cell failure of it happens? Right. So we are only focusing on the stage 1 for now.
Yeah,
so,
but that you didn't mention. So I got confused actually how this test is going to satisfy, take care of all the 3 problems associated with the battery.
Okay. Yes, sir.
Isn't it?
Yes, yes.
Yeah, and one more question now. If you are going to take care of only the stage 1,
yes.
On what basis you are claiming stainless steel and aluminium? If you are saying aluminium, is it pure aluminium or it is an alloy? First question.
Okay.
Second, stainless steel, which grade of stainless steel? And why only aluminium and stainless steel? Why not other materials?
Sir, because actually what we have done, we have researched, me and my guide, we have researched some, and we have seen that the other materials have been certainly used, like the composite material, CFRP materials have been used there. So
Correct.
we are just trying to see what happens when we use aluminum or any other material. So available material.
Now see, when you are investigating, yes, it should be a very, very planned approach, isn't it?
Yeah,
so
yes,
you should do some material selection, make use of some material selection method, try to prepare a matrix and then take a decision on the selection of material. That is what I think. And it will be a very good idea if you select the material properly by assigning different parameters and different factors. And then depending upon the results, outcome of that material selection method or the matrix results, you can claim that we are using these materials and then you can go ahead.
Yes, sir, you're right. Actually, yes, sir, I'll see into it, sir.
Okay.
Yes.
Fine. Thank you.
Yes, sir. Thank you, sir.
Any more questions from the respected judges? So shall we move to the next presenter?
Yes, ma'am, please.
Yes, sir. Thank you, sir. I would like to invite a couple, Sanir sir from to present the presentation on comprehensive review on recognizing the effect of extreme heat on poultry birds in tropical environment. Kapil sir, am I audible to you? Kapil sir, am I audible to you? Moving to the next presenter, I would like to invite Amit Shinde sir for presentation on design and analysis of trailing arm of Bajaj Auto Rickshaw.
Hello, ma'am. Actually, I will do after some time, ma'am.
Okay.
Yeah, thank you.
Sachin sir, shall we move to the next
Yes,
one?
yes, ma'am. Go ahead. Yes, please.
I would like to invite VSM Ramakrishna sir to present a presentation on an overview on anti-COVID coatings research recommendations.
Good afternoon. Am I audible?
Yes, sir, you are audible.
Yeah, thank you so much. Is my presentation visible?
Yes, sir. Yes, sir, your presentation is visible.
Is it permissible?
Yes, sir. Yes, sir.
Because I have been seeing presentations having a background of ICETET.
Yes, sir. You can proceed, sir.
Okay, thank you. Good afternoon, conference. This is Dr. Ramakrishna. I represent the Department of Metallurgical Materials Engineering, which is unique of its kind, and I work for MGIT Hyderabad. Well, this presentation is, or this talk is mainly intended to give you an overview on anti-COVID coatings. And this is not my work. I don't want to boast it, but this is some other's work, and I'm just giving you thumbs up to the work. That's it. And this presentation mainly focuses on the coatings which are given to the standard uniform, which we have been maintaining from 2020 onwards, that is mask. Because we know that we got into pandemic situation from 2020. Until now, the pandemic is running, and it will run for some time also. And these are no new to the mankind. In fact, it has been under pandemic situation for a lot of times. So, as in when we have such kind of situation, normally we look for some kind of remedial measures, some kind of protective equipment that would resist us from getting infected. Masks have become a part of our life, because the way in which the transport of the virus from man to man or from human being to human being, because it is airborne, some research says that it is airborne. So it is easy to spread the virus, to take the carrier like air and then go to the next person. And we need to apply masks everywhere and at any point of time. These are never new to us. But we need to understand that how do we disinfect the virus or disinfect ourselves from masks. So that is what the basic idea behind the presentation. Let me move on to presentation. This is the nutshell of the entire presentation, wherein I shall be introducing you about COVID-19. In fact, this is never new to all of us. We got educated and we got re-educated. And I am not going to spend much time on what exactly is COVID-19 and what are the negative impacts of COVID-19 and all, because all of us know very well and we are all aware of all these things. But the main focus is the objective behind or the objective of this work. That means the basic motto behind making or killing the virus or making an antiviral coating. And that is what the basic objective. What we have understood from the research that happened over the pandemic period is that there are some antiviral coatings available, and that would definitely make the human beings protected. And one such of coating was or is copper based. Of course, there are a lot of coatings available. We can have polymerized coatings, and we can have nanomaterials coated onto the masks. And we have got some other things like some other coatings can be done on the mask. But no, I'm selfish, a bit selfish, because I come from the metallurgical engineering background. So I would choose copper as the coating material because it interests me. And there are some case studies on copper-based coatings. We shall have some case studies and some take-home points or some concluding remarks. What exactly will make we make copper-based coatings, and what we need to, how can we publicize it all. And this is the normal introduction, that what I just wanted to give you, the background behind the pandemic situation. And the world has seen a lot of pandemics, right? From 1918, it lasted for 2 years. Then it was for 1 year, 1957, only 1 year in 1968, and 1.5 years in 2009. But right now we are having 2019 till now. So this is considered to be, or this is regarded to be, the longest pandemic the world has got. And this is a photograph or micrograph of a coronavirus virus, and that disease is a person. And this is what I just wanted to tell you, that how the virus gets spread off. It has got 3 different media wherein you can make use of, or you can have the airborne virus, where the virus travels in the air and then goes to the next person. And if you are in contact with other person, shaking hands and all these things, then you will get infected. And if there are fomites, where somebody rests his hand or her hand on some surface, and then you would also place your hand on the surface, then virus easily gets into your body, because virus doesn't see or doesn't have any discrimination. So these are the ways in which the virus goes into body. And as per the standards of World Health Organization, to avoid this kind of virus, to prevent this kind of coronavirus, we have got a lot of things where we need to wear masks, put on masks, and then keep yourself clean, and make some sanitization of your hands regularly. And if you come across any kind of symptoms, then you have to get tested and all these things. Now, these protocols, they will lead to some kind of disadvantages. Like if you keep continuously wearing masks, then you have some kind of lung diseases coming out, because over the period, we all know that we are inhaling oxygen and then exhaling carbon dioxide. So moment might come where we inhale carbon dioxide and exhale oxygen, because the masks, whatever that we inhale, whatever that we exhale, we have to inhale. So such kind of things will make the human life tragic, and we have to make sure every time that we are not touching the surfaces, or we are not getting infected, and we have to have frequent medication, and we have to make we need to be very careful when you go outside, and all these things. So these are all some shortcomings or disadvantages of these protocols. So the main objective is that as long as the pandemic exists, and as long as it doesn't turn out to be an endemic situation, we need to have some kind of preventive measures of this pandemic, where the spread of virus, the possibility of spread of virus should be decreased. And that will happen only if you have very good coatings on yourself first, or you can have coatings on the protective equipment which you use, and that is your mask. So with this, we just have reviewed what are the antiviral coatings available. And we came to know that there are several polymeric coatings and metal ions or metal oxides, nanomaterials, and all these things are the coatings that can make the virus killed. So they are all to be called as antiviral coatings. So as I told you, that I'm being selfish, and I would choose metal ions because it is easy for me to process, and I know the past, present, and future of metals, and I know how to treat them, I know how to apply them, how to fabricate them. Therefore, it is better that we go with a metal ion or metal as the thing. So some kind of theory behind polymer. So how will a polymer coating be advantageous in killing the virus? So this mechanism will make the virus get killed off, where the polymer coating, the antiviral drug, And that is how the coating will make the virus get out of the entire thing. And metal oxides or metal ions, as I told you, that this is a mechanism where the metal ions or metal oxides or the metals in particular, they completely kill the virus. So this mechanism is very simple, that the metal ions are the blue colored balls, and that we have got virus, and these two get interacted, and the metal ions have got the ability to kill the virus. And we have got nanomaterials, because it has been buzzing all over. And these materials for everything, we go with nanomaterials for every, for all locks, the key is nanomaterial. So the viral factor, the cellular factor, and all these nanomaterials also are able to kill the virus. But finally, nanomaterials are something which are cost effective in nature. To produce them is something which is very difficult, and they might catch a hold of oxygen very quickly. Reactivity matters, and production matters, and we cannot really prevent them from chemical reactions. And this is the schematic representation how copper can disinfect the virus. So this is simple, understandable slide, wherein the copper ions which get generated, so they kill the virus and the virus gets killed. So these are the steps which are the mechanism which people have thought of. Why, how can copper be a disinfectant and all? So the case study that what we have got from the research papers is that how will a copper coated polypropylene mask work in case if you undertake some kind of characterization, some kind of tests, then analyze the properties or the outcomes of the entire characterizations. Then you compare with the standard things, and the RT-PCR test can be done on the mask itself. And you would understand how this RT-PCR test of copper coated mask, and which has got the virus in it, and gets nullified. So such kind of things we have to perform. So we have taken a case study. And this is outcome, the KF94, which stands for Korean filter 94. 94 is the percentage of filter efficacy. Efficiency of the filtration is 94. That's how it is called KF94. The trade name is Kleenex KF94 masks. Then we have gone with, not we, I'm sorry, that is the research has gone to deposit copper onto the masks, wherein they used a process called ion beam treatment and copper sputtering deposition. Because deposition has got different ways of, you can deposit the metal. Electrolytic deposition is there, chemical vapor deposition, physical vapor deposition, and one of that is sputtering deposition. So copper gets sputtered onto the mask and through ion beam treatment, and that is how the mask will get the copper coating. After the outcome is out, then we have to treat it, characterize it. We need to understand the electron microscopy. We need to understand whether the film is adherent to the mask. We need to understand whether the film is or the mask is filterable. Can it filter off? And we need to understand the antiviral effect against the virus and RT-PCR, real-time polymerase chain reaction. And then we need to suggest that the copper coating does well. In case if you use this copper coating, then you can have antiviral kind of things. So this is the outcome after coating. This the mask has been coated with the copper. Then we have gone with characterization, wherein we have gone with electron microscopy. Initially, we have taken the mask, which is non-coated, the mask which has been coated. So we have taken there is the research has been done on the electron microscopic studies of coated and uncoated copper masks. Then it is understood that the tubes or the layers which we have got, which the micrograph shows, will have some copper particles in it. So if you could peep into it, then you will be finding the copper particles which are embedded into the layers. Then the adhesion testing was done, wherein the uncoated and the coated, and the results also were good. Like the adhesion, the film, the thin film which has been formed on mask was completely adherent. It was binding the mask like anything. And the analysis of the entire characterization, wherein you got KF94 which is infected and copper coated KF94 from 1, 2, 3, 4, where the increase in the amount of copper from n is equal to 1 to n is equal to 4. And these are all various biochemical or biological tests that have been done on the copper coated masks. And this is a comparative study where KF94, which is copper coated, and KF94, which is uncoated, the reference. wherein it was found that 95.1 filtration for NaCl solution and 91.6 filtration for paraffin oil, whereas the reference, the uncoated copper mask, has got 99.9 filtration and 99.3 filtration, which means that this also indicates that there is adherence. The film has completely spread over the copper mask. In case if the film is not spread over, then you would have definitely have a filter. That means this is the thing that is the efficiency of filtration. So it has got some pores. If the film is continuous, then there are no pores, less filtration. That is the driving force behind it. And this is the CT value, the cyclic threshold value, CT value that was performed on coated, uncoated, then uninfected, infected with the mask, infected with copper coated mask. Now you see that these two values are matching each other. There is uninfected is equivalent to infected copper coated KF94 mask. So which shows that copper coating was efficient in making or in killing the virus. And these are some take-home points. We all know that the mankind has always been impacted with few unforeseen pandemic situations, but every pandemic situation has taught us a good lesson. That means we have to be very careful. We have to undertake a lot of preventive measures. We have to go ahead with that kind of preventive measures. And COVID-19 is the ongoing pandemic, which also has been causing, it has been being addressed by a lot of scientists and researchers, and they're all in the process of bringing out an appropriate preventive measure. So of recent, the research outcomes on copper-coated KF94 masks show promise consequential as antiviral PPE kit for SARS-CoV-2 inactivation. So finally, I would recommend this kind of coatings, copper-coated masks. They are going to be very advantageous in killing the virus and then safeguarding the mankind. Thank you so much for your attention. Thank you so much. I'm open for discussion. I'm open for discussion. The talk is open for discussion.
Good afternoon, Ramakrishna sir.
Very good afternoon, sir.
Sir, it was a very, very nice and interesting presentation. And I personally am associated with the Indian Institute of Metals Pune chapter, sir.
Oh, glad to know, sir. Glad to know. Very glad to know, sir.
And my area of work is also in coatings, but I'm going for materials related to gauges.
Sir.
So it was really nice presentation, sir. The only question which I have is, we are using the sputtering technique. So base material of the mask and metallic ions. So are we getting the results actually?
Yes, sir. In fact, sputtering is having no discrimination, sir.
Okay.
You can sputter the material onto any kind of surface, it can be metallic, non-metallic, glassy, polymeric, wood. You can make it such kind of thing. But only thing is adhesion, sir.
Yeah.
The adhesion point of view we have to think of, and this fortunately resulted a very good adhesion.
What is the material for the mask?
Polymeric material, sir. It's a
polymeric material.
Yeah.
So it might be having some pores.
Yes, exactly, sir.
And this metallic ions are getting fitted into the pores, sputtered onto the pores.
Yes, yes, yes.
Very nice and very interesting presentation, sir. How much this mask costs, sir? Any idea?
It costs more, sir, because to gain something, we have to do something.
Yes, yes. But this might be used in the research laboratories where the investigative study is being conducted for COVID.
Exactly, sir. Because no, we have to have this kind of uniform for a longer time, sir. Mask has become a part of our life. Not only the teachers or the things, no, researchers and even doctors also have to put on masks. So
yes, sir. Yes, sir.
This has got long lifetime. The first thing that what I can assure you is that the lifetime is very good, sir. The cost effective, it is also always cost effective because the process itself is sputtering process, which itself is costly in nature. So
yes,
you can have.
Is it reusable, sir? I mean,
yes,
after certain time.
Yes, sir. It is reusable, sir.
Okay. Just for an idea, sir, how much it costs?
Yeah, it will be more than 3 to 4 times of the regular KF94 masks.
Okay.
Because a lot of coated masks have been into the market as of now, sir.
Yeah.
Like some people have researched on carbon nanotubes coated masks. CNT coated masks.
Yeah. Okay.
And silicon coated masks.
Okay.
But copper is very advantageous because it doesn't harm you, sir, first of all.
Right, right.
And it has got very generosity. It is very generous. But carbon nanotubes and silicon, at some point of time, if you inhale it more, then you may have the inhalation of all these particles into your lungs.
Yeah, correct, correct.
That
it might create more complications again.
Exactly, exactly.
Yes, in this COVID situation, the water from copper vessels was recommended. That might be the reason.
Yes, yes. So because we are all going back to our olden days, sir.
Old traditional terms, right?
Yeah.
Exactly,
So,
sir.
Copper has been our king metal at some point of time.
Yes, yes.
Now it has become, gold has preceded copper. For engineering applications, titanium is always there as noble.
Yeah, yeah, correct, sir.
Yeah.
Sir, can you share your contact details, please?
Right now, sir?
Yeah, please.
Yeah, my contact number is 98.
Yeah.
49.
Right.
58.
Okay.
83. 76.
Okay.
And can you please repeat it, sir?
9849588376.
True, sir. That's it.
Yeah, and your email ID, please, sir. If you don't mind.
My name is there, sir. RVSM Ramakrishna.
Yeah.
RVSM Ramakrishna _
Yeah.
My department MME, Metallurgical and Materials Engineering, sir. MME.
Right. All small letters.
All small letters, sir. At the rate.
Yeah.
My institution MGIT.
Okay.
.ac.
Yeah.
.in.
Okay, fine. Actually, we are organizing national and international level workshops in our institute, sir, in association with IIM Pune chapter.
Glad to know, sir.
So we get a lot of participants from DRDO and all the research institute organizations across India.
Yes, yes.
We have a good number of speakers from DRDO, HAL, so all sorts of IITs. Okay. So definitely in that context, I will definitely contact you, sir. Maybe in the near future, we are planning a workshop again, because since 2 years, it was not possible. So we are trying to revamp the workshops. So maybe in the month of September, I'll contact you, sir.
Thank you, sir. I'm always obliged, sir. I have.
You might be knowing Dr. N.B. Dhoke, sir, from IIM Pune chapter. He was his head of metallurgy department at COEP.
Oh, okay. Very good, sir.
Yeah. I am always closely working in association with him, sir.
Oh, okay. So pleasure to know, sir. Pleasure to know.
It was nice talks and nice presentation, sir.
Thank you so much, and I'm always at your disposal, sir.
Yeah, definitely, sir. I will contact you in the context of the workshops.
Sure, sir. You can count on me, sir, at any point of time.
Thank you very much, sir.
Thank you so much, and thanks to organizers, because otherwise I would not have had a chance to talk to you, sir.
Yeah. Thank you very much, sir.
Thank you so much. Can I stop my presentation, sir?
Yeah, please.
Yeah.
Thank you so much, sir.
Thank you very much, Diya madam.
Thank you, sir. So can we move to the next presenter?
Yes. It was really very nice presentation, madam.
Yes, sir.
Yeah, we can move ahead, ma'am, please.
Yeah. Thank you, sir. I would like to invite Bhavik Sharma, sir, to present on finite element analysis of stainless steel and titanium femur implant for total femur replacement. Bhavik, sir, are you present?
Yeah, ma'am.
Yeah.
Good afternoon, everyone.
Good afternoon, Bhavik.
Please let me know if my screen is visible.
Not yet, sir.
Yeah, I'm doing. Now?
Yes, sir. It has started sharing. Yeah, it is visible now.
Yeah, thank you, ma'am. First of all, my name is Bhavik Sharma. Right now, I'm pursuing my MTech in design engineering from the Department of Mechanical Engineering, which is in the MIT School of Engineering, Loni Karbor. And as my guide, Professor Anurag Nema, we are working on this as a finite element analysis of stainless steel and titanium femur implant for total femur replacement. Total femur replacement is a new concept right now. A lot of research is going on. So I have just tried to add some on this. So moving further, also along why this topic, as I'm also a cricketer, along with my educational field, I have also faced a lot of injuries in the bone, in the muscles, and again, my grandfather have been through 2-3 major surgeries related to femur bone. That's why I've chose this topic. And also as we know, after 35, right now after 35 or 40 age, the osteoporosis is also increasing. This is the kind of logic or story behind this topic. This is the overall content of my presentation, starting with the abstract, introduction, literature survey, problem statement, objectives, methodology, conclusion, and references. Moving towards the reference abstract, here I have mentioned the application of finite element analysis in the medical field, how we are going to use, and also we have mentioned the objective of the study means to reduce the bone replacement cost along with the reusable bone implants, and also the implant rigidity, which is similar to natural bone or more than the natural bone. Instead, the study is to bypass the need of replacement and the multi-year functionality. And at last, I have concluded the comparison between the stainless steel and titanium alloy, which I have used in the study. Stainless steel, here I have used the SS316L, and then titanium alloy, which is a TI6, with a combination of TI6AL and 4V. Here I have evaluated the results on the femur bones made of bone, stainless steel, and titanium under the load of 50 to 70 kg, which is ranging from incremental of 5 kg, means 50, 55, 60, 65, and last 70. Moving on, introduction. Finite element analysis is the effective theoretical analysis for the mechanical behavior of mechanical engineering. Using the FEA, we can evaluate the mechanical behavior of any biomedical parts, means including a bone, or right now we are into a neural network, so we can calculate or evaluate each and every results using the FEA. Here I have used the ANSYS. Means ANSYS runs the few algorithms or a mathematical model in the background to evaluate those results. During FEA, the most essential is to apply the correct boundary conditions. And an orthopedic implant is a medical technique developed to replace a missing joint for a bone or to support a fractured bone. Yeah, I propose the total femur replacement, which is also known as a total femur arthroplasty, means a TFA. Total femur replacement is a surgical process that replaces the femur bone in order to repair the maximum fractures or which are extremely complex to be repaired using the prosthesis. And also TFR is useful in the extreme condition of the osteoporosis, where the doctors can't operate the bone, or means the bone is not in the state to support the implant. So where we can use the TFR. Here I'm proposing the replacement of femur bone using the bones made of metals. Instead of using the implants and prostheses, you can replace the bone fully made of the metals. The various types of materials used for the prostheses are the metals, polymer, and the ceramics. The metals that are used are the stainless steel, cobalt-based alloy, and the titanium alloy. Moving on, here are the few literature surveys which I've come to know about the finite element analysis in brief, and how I can apply the FEA to the femur bone. And in the next one, I have studied or have found the titanium, about the titanium material, about its density, how the patients feel after the implantation using implant which are made of titaniums, and the biocompatibility of the titanium in the human body. These are my findings in those literature survey. Again, the third one, there are the various materials which are used and which can be used to make the implants, and also the which are commonly used that I have already mentioned. The commonly used metals are stainless steel and the titanium alloy. In the last one, there was a study on the composite material, the polymethylene metacrylate thermoplastic. But I'm not into that composite materials. Here I have included one case study, means to validate my topic that total femur replacement is possible. So there are the author I have mentioned here. They have studied it. They have this case which they have in the figure A. You can see the it's actual femur bone they are going to replace, and in the figure B, the assembled modular total femur replacement, which is made of a 203 material, and they have assembled the parts. Means they have manufactured the stem differently, they have manufactured the femur head differently, and stem and the distal part of that femur they have assembled. But to replace this, to bypass this process of assembling, I'm proposing this idea that to manufacture the whole bone of a single material without assembly, means a fully intact bone, I'm trying to say. And in the figure C, you can see that they have implanted or operated the new manufactured or assembled femur bone. Moving on, these are my few problem statements which have came through the literature survey. The metal incompatibility with the fluid inside the body means it leads to corrosion, it leads to fungal infection, and the uneasiness to the patient, and also the magnetism effect of the metal. Means while doing the MRI or the CT scan, the metal react to those magnetic field. So then the results won't appear. Also to reject this problem, decrease in the bone mass and increase in bone porosity. This is also a major problem which leads to osteoporosis and leads to fracture. Difference in the elasticity and the metallic implant and the bone may cause a loosening the effect. Moving on to the objectives, means to lower the cost of bone implant, to recycle the bone implant. Also, it needs the higher strength, stiffness, and the more similarity to the nature of the bone. Also, the lightweight of the femur bone or implant. These are my few objectives which have come through the literature survey. Methodology. This is a general structure which I have divided into 5 steps. This is a FEA general structure. And so first we have to create or import femur geometry. Then we have to discretize is means dividing into a smaller parts. We also call it as a mesh. Then we will implement the boundary conditions on that. We have on the bottom of also have mention the material properties which we are going to use in the boundary conditions. Talking about the boundary conditions, as you can see the figure on your right, the blue color shows that the femur bone is fixed at the distal part, and the pressure is applied at the femur head, which is in the negative Z direction, which is highlighted with the red color. Then moving on to the solution part, we will require the stress, strain, the deformation. Then we can evaluate using the FEA. The material properties which I have used over here, I have mentioned for the bone material, for the SS316L, and for the titanium alloy. For the densities, Young's modulus, and the Poisson's ratio I have mentioned over here. The figure on the left is the mesh is the meshing of that bone. Here I've used the 1 mm size for meshing. Moving on to the results. As I have mentioned earlier, the FEA helps to evaluate whatever the stress, strain, deformation be required. We have evaluated and have compared those stress, strain. The results I have added here is actually at the 490 Newton, means at the 50 kg. Why 50 kg? Because it's the average weight of a human body. But in the human body, the both femur act as a supporting member for the entire weight. But here only 50 kg is applied on a single femur. So in a real life or real life condition, it will be more than 50 kg. So the first figure means starting from the left, it's for the bone. The second one is for the stainless steel, and the third one is for the titanium alloy. All the femur shows the maximum stress developed at the proximal part of the shaft. Means it's also after the femur neck. The minimum cross section is at the proximal part of the shaft. Means the maximum stress developed is at the proximal part of the shaft. And the fracture can be occurred at that position. Then these are the strain values. Again, at the top left is the of bone, and the second one is of stainless steel, and at the bottom it's of titanium alloy. And on the right side, I've mentioned the table respect to the load at the 490, 540, 590, 640, and 687. These are the loads I have used. And according to material, how much the stress develop and the strain develop, I have also mentioned over here. For that, I have added the comparison using the chart. So moving forward. On the left side, I have plotted a chart of the stress results. Here you can see that the light blue color, which is the equivalent stress of the bone. In orange color, I have mentioned the of stainless steel 316L, and titanium, which have used the black color. And so over here, the equivalent stress of bone and the equivalent stress of titanium alloy are overall more or less the same. They are overlapping to each other. Whereas the stress developed in the stainless steel is much less than this as compared to the bone and the titanium. And on the right side, there's a chart of equivalent stress in all the three specimens. Here also the strain developed in the stainless steel is much lesser than the bone, and it's more or less the same as compared to the titanium alloy. Though the stress developed in the titanium is match the stress developed in the bone, the doctors or the study shows that the titanium in those superior to go with in the manufacturing of implant. Here's the conclusion. The stainless steel is resistant to corrosion. That's why all the implants and the prostheses are manufactured of the stainless steel and the titanium, because both are resistant to corrosion, and it does not pose the higher risk of causing the infection when it comes to the contact in the fluid inside the body. Though the titanium is prized material for the superior strength, it is highly durable, resistant to load, and yet very lightweight. As I've mentioned in my previous slide, the Young's modulus is pretty much less as compared to stainless steel. That's why its resistance to load is more. Both the material shows more or less mechanical strength, when the strength is similar. The titanium shows less deformation than bone and stainless steel. I've also calculated for the deformation, but I've not included in my presentation. The bone is slightly expensive than stainless steel, and so if titanium is around 600 1,600 rupees per kg, and whereas the stainless steel is 1,000 in the range of 1,000 to 1,100 kg rupees per kg. And also the advantage, and as I have mentioned in my problem statement, that the magnetism effect of the metal, the titanium shows the MRI results, and whereas the stainless steel don't. These are the few references I have mentioned over here. That's it from my side. Thank you. I'm open to question answer.
Thank you, sir. Any questions from the respected judges?
Hello.
Yes, sir.
Yes, sir.
Yes, Mr. Bhavik, you have referred to one of your reference as your validation point. So that should not be the case actually. You have referred to that paper. You showed the images of assembly and a single one-piece femur bone, isn't it?
Yes, sir, this one.
So how can you claim it as validation? This is a case study you are saying, no? Case report.
So not as my study validation, but as a topic, which as it's a new concept. If I have also gave this presentation in my college seminar, where they raised the question that from where you can claim that that total femur replacement is possible. So at that time, I didn't add this case study. So that's why I've included.
Yeah, this is a reference. This is a reference actually.
Yes, sir.
But have you gone with the manufacturing of these femurs, whatever you mentioned with the material selection?
Oh, no, sir, it's still under process.
So it is simply you have made use of the software and you have
Yes,
done the
sir.
FE.
Yes, sir.
And this is a master's MTech level project?
It's still incomplete. Then we are adding the data optimization. Which I have a data set for the age, weight, height, and the bone mineral density, which we are going to predict using the code.
Okay.
That's the second half of this. And so in the input, we'll give the age, weight, and height. And in the output, we'll get the bone mineral density. After that BMD value, and so bone mineral density value, will predict that this patient needs to be that femur replacement or not. Means does he have the osteoporosis or not? Yeah. It will read of continuous checking and the operation process here.
I don't think you will get any validation for your work as such. So you have to try for a good number of experts who are in the joint replacement.
Yes, sure. I will.
You're from which place?
My native place is Akola, but right now I'm in Pune.
Okay. Because whatever the joint replacement agencies and hospitals are available, they are importing these implants from companies like renowned companies like Johnson & Johnson, I suppose.
Yes, sir. There are a few in India also, like Merrill Silva sites in Gujarat.
Yeah.
Yes, sir.
But you'll have to contact these companies for validation.
Yes, sir.
And simply doing analysis will not suffice the purpose actually.
Yes, as I've said, it's under process. The rest half is under process.
Okay. No more questions from my side.
Thank you, sir.
So I'm having a question. Can I please?
Yeah, please go ahead.
So there is you have used the titanium implants in it. So what kind of coating these implants having? Like SLA coating or graphene coating? As implants, they have a similar modulus of elasticity, just like the cortical bone and all. So
Yeah,
which coating on these implants?
Ma'am, there are two types. of prosthesis or implants. They are metal on metal. Some are plastic on metal, metal on plastic. But out of those three, I have not included so far in my study yet.
Sir, but there will be some coating. How it will osseointegrate in bone once you are launching it in that place? So there will be some coating in that implants.
Sorry, ma'am, I have not considered those yet.
Okay.
I have to study that. I will.
Okay. Thank you so much, sir.
Yeah.
Any more questions? Sir, can we move to the next presenter?
May I stop the sharing, ma'am?
Yes, sir.
Thank you, everyone.
Thank you, sir. I would like to invite Prashant Amle, sir, presentation of on experimental investigation of process parameter in turning using design of experiments. Prashant, sir, am I audible to you? Prashant, sir, am I audible to you? Sir, can we move to the next presenter with your permission?
Yes, ma'am. Yes, go ahead, please.
Yes, sir. Thank you, sir. I would like to invite Prasad Kulkarni, sir, for presentation of optimization of total cycle time of tempering process. Prasad, sir, am I audible to you?
Hello.
Yes, sir.
Ma'am, can I take 5 minutes? There are some technical issues to present the PPT. Can I?
Okay, sir. Okay. So we'll wait or should move to the
No,
next?
we can move ahead, ma'am.
Okay. Second presentation also from Prasad Kulkarni, sir, for review of eco-friendly cleaning machine. Okay. Like to invite Professor S.B. Ambarkar, sir, for presentation on design and fabrication of slag packaging machine for agriculture applications.
Hello.
Yes, sir.
Yes. Once again, let me just share the slide.
Yes, sir. Yes, sir. Treatment analysis. Yes, sir. Are you present there?
Yes, one second.
Okay, sir.
Actually, ma'am, there is some issue. I'm not able to share the presentation.
Okay, sir. So you can present after the next presenter.
Okay, ma'am.
Yeah, thank you. Moving to the next presentation, I would like to invite Nirbhay Yadav, sir, for presentation on effect of working fluid and pipe material on performance of heat pipe. Nirbhay, sir, are you present there? Am I audible to you? Nirbhay, sir? Okay. I'd like to invite our next presenter, Shubham Raje Vag, sir, for presentation on design and development of fatigue testing machine. Shubham Raje, sir, are you present there? Okay. I'd like to invite Akash Gaikwad, sir, for presentation of hybrid electricity generation on highway. Akash, sir. Akash, sir, am I audible to you?
Call the next one.
Yes, sir. I would like to invite Sushil Nikhade, sir, for presentation on design and fabrication of coin-operated portable mask vending machine. Sushil, sir. Sushil, sir, am I audible to you? Are you present there? I would like to call Bahare Madhuri, ma'am, for presentation on development of virus bacteria disinfection box using UVC chamber, ultraviolet rays.
Hello.
Yes, ma'am.
I'm audible, ma'am.
Yeah, you are audible, ma'am.
Okay. Is it visible?
Yeah, it is visible, ma'am. You can proceed.
Okay, ma'am. Good afternoon, everyone. Myself, Madhuri Bari, and I'm from SIM Mechanical Department. Our project name is Development of Virus Bacteria Disinfection Box using UVC ultraviolet light. And it is guided by Professor Dr. G.N. Sherke, sir. So, abstract. From this COVID-19 pandemic, we all know that the importance and need of disinfection in order to overcome the problems which arises from viruses and bacteria. So the attempts are made to develop the virus bacteria disinfection box using UVC light. So it is a device which kills virus and bacteria from a surface of various gadgets which cannot be normally disinfected by traditional cleaning or disinfection methods. So there is a wide range of light in which UV light is mostly used in industrial, medical, dental practices for many purposes like killing bacteria, creating fluorescent effects. So UVC is the most harmful wavelength among the UVA and UVB. Therefore, we choose the UVC light is used in our disinfection box. So here are some objectives of our project. first is disinfect electronic gadgets and objects that cannot be sanitized by sanitizer. And second is the current disinfection box in the market is costly. So objective is to reduce the cost and maintain the same effect. Third is the disinfect objects like mobile, watch, electronic gadgets, jewelry, money, books, or packaging food, etc. Fourth is current market price of disinfection box is starting from 5,000 and onwards. So we want to make it affordable for everyone. So what is the importance of disinfection? So the disinfections and sanitization is important aspect. Cleaning and disinfection involves the many physical and chemical processes to reduce or remove or inactivate or destroy the harmful microorganisms. And from pandemic, people are aware of importance of isolation, disinfection, and personal hygiene. So basically, ultraviolet rays are distributed in three types. Ultraviolet A, which ranges from 315 to 400 nanometer. Ultraviolet B rays ranges from 280 to 315 nanometer, and ultraviolet C rays, which ranges from 100 to 280 nanometer. UVA is the longest wavelength and it present in majority in atmosphere and causing skin tanning. UVB is the second shortest wavelength, and there is a strong link between the UV rays and skin cancer. And UVC is the shortest wavelength among UVA and UVB, so it is most harmful. It have high intensity though and small wavelength, so it is more harmful. And it completely absorbed by ozone layer. So here are some sterilization properties of UV rays. So UVC is the most traditionally referred as a germicidal UV with ability to kill virus, bacteria, viruses, mold, or fungi. UVA and UVB wavelengths also demonstrated effectiveness against certain viruses and bacteria. So viruses and bacteria are made up of cell, protein, or lipids. So UV light causes oxidation of that protein, the lipids, and it causes cell death. So UV dose is calculated by this formula, that is UV dose is equal to UV intensity, that is measured in microwatt per centimeter square, and into exposure time. So exposure time start with 20 or 30 seconds onwards, and result is expressed in microwatt second per centimeter square. This is a log kill rate table, which shows the percentage reduction in log 1, log 2, log 3. And this is 253 nanometer. This is a peak germicidal value of UVC light. So these are the experimental setup. Wooden box of 18 by 12 by 9 inches. UVC light of 11 watt. Choke adapter, bell push switch, and aluminium foil for reflective surface. Procedure: through choke and adapter, bell push switch is connected, and just connect the plug to main power supply. Put the accessories inside the box, and make sure objects should not overlap on each other, and on the main switch, and press the bell push switch for 20 to 120 seconds according to number of accessories and size of accessories. So here are some safety measures of precautions to take. Germicidal lamp, UVC radiation, it is most harmful, and it is harmful to our skin and eyes. So switch off power to UV light before opening your disinfection box, and place the device in clean and dusty area, and clean the inner and outer surface periodically. Keep the device away from children, and don't on switch for too long. So application, there are various applications of using this disinfection box. We can use this virus bacteria disinfection box to clean the gadgets, accessories, electronic devices like laptop, mask, fruit, vegetables, packaged food, money, books, and many more. And we can use this disinfection box in school, college, working, office area, clinics, hospitals, some small laboratories, banks, etc. Conclusion: the 31-liter capacity disinfection box is developed in order to develop disinfection box. The various germicidal properties of using various germicidal properties of UVC light, and characteristics were studied and accordingly that utilized. Disinfection box is successfully operated to disinfect gadgets like electronic devices, money, books, masks, etc., which cannot be disinfected by liquid or gel sanitizer. Here are some research papers that we referred while studying, doing the project. Thank you.
Thank you, ma'am. Any questions from the respected judges?
How much is the cost of the total setup?
Sir, probably the 1,900 cost.
Okay. Is it commercially available?
Yes, sir, it is commercially available on various websites or stores.
Okay. Same specifications?
Yes, sir, same specification, capacity mainly.
Okay. Yeah. No questions from my side, ma'am.
Okay, sir. So can we move to the next presenter?
Yes, ma'am, please.
Yes.
Thank you.
I would like to invite Tejas Dore, sir, for presentation on development of direct contact heat exchanger for removal of tar in FBG.
Yes, ma'am. Wait, I'll present the screen.
Yes, sir.
Hello?
Yes, yes.
Hello, I'm audible?
Yes, sir, you are audible.
Okay. Yes, ma'am. Please wait.
Mm-hmm.
Ma'am, can you see the screen?
Yes, sir. It is visible, sir.
Yes, good afternoon all. My project is based on the development of direct contact heat exchanger for removal of tar in fluidized bed gasifier. And my name is Tejas Devre, and this project is guided by the Professor Dr. G.N. Sherke. The direct contact heat exchanger involves the exchange of heat between two immiscible fluids by bringing them into the contact at different temperatures, like different temperatures and different fluids, like we can say that solid liquid or liquid, and the burnable gas is produced from the gasification of biomass in circulating fluidized bed gasifier developed in the laboratory. The fluidized bed gasifier consists of the producer gas consist of CO, H2, CO2, H4, etc. And this gas also presents of some type of tar or hydrocarbons. And tar is basically a heavy hydrocarbon constituent and sticky in nature, and it is obtained in a vaporized from along the humble gas and gasification process. When it enters into the combustion chamber, the motion between the piston and hydrocarbon resists to the sticky nature and of the tar and burnable gas. And the tar is a heavy hydrocarbons, and it is difficult to break down in the combustion process. That's why there is a major problems are created, like it can clog the engine components and require frequent maintenance, which increase the per unit production cost of syngas. For the utilization of syngas, the internal combustion engine, that's why it is very important to remove and separate the tar from the producer gas. there are some objectives of direct contact heat exchanger to develop a tar removal unit, the effective tar removal unit. And second is to develop a direct contact heat exchanger, and to develop the cyclone separator for the separation of tar and the producer gas. This is the introduction to the direct heat exchanger. The heat exchanger is basically a system used in transfer the heat between two or more fluids. Heat exchanger are used in both cooling and heating processes. The fluids may be separated by a solid wall, preventing mixing, or they may be in a direct contact. And they are widely used in space heating, refrigeration, air conditioning, power stations, chemical plants, and petrochemical plants, etc. The classic example of heat exchanger is found in an internal combustion engine, in which a circulating fluid known as engine coolant flows through the radiator coil and into the spark coil, which cools the coolant and heats the intermediate. This is a direct contact heat exchanger. The basically direct contact heat exchanger is the exchange of heat take place in the direct mixing of hot and cold fluids, and the transfer of heat take place simultaneously. And the basic example which we can use a direct contact heat exchanger is the cooling towers, jet condensers, and direct contact fields. The direct contact heat exchangers makes the use of gas-liquid phase change in heat transfer within the working fluid. And the streams, like the various streams are used in the direct contact heat exchanger. Like we can use the gas solid, gas liquid, liquid liquid, liquid solid, or solid solid streams. The direct contact heat exchanger involves the heat transfer between cold and hot and cold streams of two phases of the absence of separating wall. And thus such heat exchangers are being classified as a gas liquid, immiscible liquid liquid, and solid liquid or solid gas. Most of the direct contact heat exchangers falls under the gas liquid category, where the heat transfer between gas and input the form of drops, films, and sprays. This is the figure shows the direct contact heat exchanger working. We can mix the hot gas and the cold fluid by the direct mixing of hot gas and cold fluid in the direct contact heat exchanger for the further processing. The application of direct contact exchangers are basically used in the open feed water heaters in the power plants. Second one is the open evaporator cooling towers, barometric condensers throughout the petroleum industry, in-gas separation plants, another use of the absorption refrigeration plants, and rotary retorts and drying processes. There are some advantages of the direct contact exchangers. It is a direct contact heat exchanger is simple to design and construct, and it can also used in removing the corrosion and falling problems associated with the closet heat exchangers. It's also lower the pressure of drop associated with the direct contact as compared to their tubular counterparts, and the reducing capital cost also. This is our project setup, experimental setup, that it consists of direct contact heat exchanger and cyclone separator. There are some components, the heat exchanger, cyclone separator, water spray nozzle, pipes, and storage tank. The procedure of our experiment is the syngas collected from the fluidized bed gasifier is given to the inlet to burn from the tar removal unit, and the water at the atmospheric temperature is supplied to water inlet for the tar removal unit, and the mixture of syngas and water which is passed through the open heat exchanger is further processed into the cyclone separator, and the tar obtained from the cyclone in a container. Basically, the gas obtained from the producer gas is direct giving the contact with the water, and the mixture of water and the fluid producer gas is can conclude the present tar and hydrocarbon material are mixing with the water, and the heavy water mixture of the tar is separated by the cyclone separator, and the condensing gas is further separated by the cyclone separator, and the free syngas produced from the cyclone separator is further goes for the purification. It is the simply our direct contact heat exchanger tar removal unit in line with the fluidized bed gasifier. there's a conclusion. The present setup is useful to separate the tar from the syngas, and it is observed that the considerable amount of tar is removed from the raw syngas. And the future scope is the syngas filtration unit can be developed for the further purification of syngas, and this gives a higher conversion efficiency. These are some references we use for our project. Thank you.
Thank you, sir. Any questions from the respected judges? Any questions from the respected judges? Thank you, sir. I would like to invite Prasad.
Hello.
Yes, sir.
Yes, ma'am. Yes, ma'am. Sorry, I was receiving a call actually at that time.
No worries, sir. So can we move to the next presenter?
Yeah, no issues. Yes, ma'am. Yes, please.
Sir, any questions to the Tejas Dure, sir?
No, actually, I have earlier listened to this topic.
Okay.
Yeah.
Thank you, sir. I would like to invite Prasad Kulkarni, sir, for presentation on optimization of total cycle time of tempering process. Yash Pathak, sir, are you present there?
Yes, ma'am.
Yeah. Share your screen.
So presentation visible?
Yes.
Our project name is Design and Fabrication of Silage Packaging Machine for Agriculture Applications, guided by Professor S.B. Ambekar, sir. So while we are thinking about how to elevate the hardships of the farmers with the intention of doing something new in agriculture, and we came with the idea that the dairy business associated with the agriculture and the fodder for the animals on which the dairy business is operated. It takes a lot of effort and manpower and keep up with the current situation with the modern technology. So we started thinking about the silage packaging machine. So basically, silage is a food for animals, dairy animals such as cows and buffaloes, which came from corn and byproducts of corn and etc. So the silage making is a fermentation process aimed at preserving the forage in its wet state away from the air.
INSEM मी इंडस्ट्रियल इंजिनिअरिंग घेतलंय आणि सर्फेस इंजिनिअरिंग दोन्हींचे घेतले. हॅलो. हा, INSEM एक्झाम म्हटलं इंडस्ट्रियल इंजिनिअरिंग आणि सर्फेस इंजिनिअरिंग दोन्ही घेतले. तुम्ही काय एनर्जीचं काय म्हणत होते?
Hello.
Yes, you continue. Hello. Yes, continue.
Yes, sir, you can continue, sir. Sorry for the
So silage making is the fermentation process aimed at preserving the forage in its wet state away from the air, in which the traditional method for the silage packaging is a farmer physically presses the silage at a container and removes the air from the silage particles. by pressing it by foot or by some other means. So in this, our main objective of the project is to reduce the effort and time required for the silage packaging for the farmers with the aim for medium and small scale farmers with some sort of automation. So our silage packaging machine consists of main base frame, the cylinder base shaft, which is connected to a cylinder base, a double acting cylinder for the compression, which is connected to 5x2 toggle DCB valve. So this is the 3D model of our silage packaging machine. So there are some advantages: high effectiveness, high durability, high reliability, simple in design, high adaptability to the harsh environment, easy selection for speed and pressure, environmentally friendly. There are some limitations or disadvantages which consist of noise. It also required external load, and it is relatively less in accuracy. So there are some future improvements we can do in this machine, such as we can automate the manual pouring and also manual removing of the silage bags. We can also improve the accuracy by automation in the rotating base disc. So for the conclusion, it is observed that the performance of the silage packaging machine is changed according to manual feed, so that the time required for the silage material transfer also changed. While concluding this report, we feel quite fulfilled in having completed the project assignment well on time. We had enormous practical experience. And also the time and effort required for the farmers for producing and packaging of the silage is reduced extensively. So thank you from my side.
Thank you, sir. Any questions from the respected judges?
Yeah. Have you done the review from visiting various farmers?
Oh, yes, sir.
So what is the outcome?
Yes, sir. So while packaging the silage, the main effort of farmer is put when main effort of farmer is when he compresses the silage manually. So there is a major reduction in the effort of farmer, and we get the feedbacks from the farmer. So they said it is very helpful.
Okay. So is it the case that few of the farmers have approached and asked you to install this system at their end?
Yes, sir. There is a village near Nashik where we take the feedbacks from the farmer. It's called Parshe.
Okay.
Where we demonstrated and also received some feedbacks from the farmer.
Not the feedback. Anybody is ready to install the system. He wants the system fabricated from your side and want to use it. Hello.
Yes, sir.
Do you have any inquiries as such that you want the system to get installed?
Yes, sir. They are ready to install it and for use it for their applications.
So how much costing you are provided?
Sir, it's around 7,000.
So they are ready to invest 7,000.
Yes, sir.
Good. Is there any possibility to reduce the cost?
Sir, this cost is for one unit. of so for mass production, we can reduce the cost.
Yeah, you can optimize so many parameters. Huh? It can come down to almost 50%.
Sorry, sir.
The cost can be reduced to almost 50% if you work on it.
Yes, sir. We are working on it.
Okay. Okay, this is from my side. Any other questions are most welcome. Hello.
Yes, sir.
Yes, ma'am, please.
So can we move to the next one?
Yes, ma'am.
Yes, sir. Prasad Kulkarni, sir, to present review of eco-friendly cleaning.
Yes, ma'am. No, ma'am. Actually, we are presenting optimization of total cycle time of business process. The another one.
Yeah, number 12.
Yeah.
Optimization of total cycle time of tempering process.
Yes. No, sir. Actually, business process. There is bit change.
Okay. Business process.
Is it visible on screen?
Yes.
Our title is optimization of total cycle of time of business process. First of all, I'm very thankful to our guide, Professor Prasad Kulkarni, for guide us very well. This project is actually based on a case study. So what we actually have, what we actually done is reducing the total time and the manufacturing time, or actual lead time of the manufacturing process, which we were reducing by replacing a process. So first of all, we were a case study on small scale industry, and then we moved towards the large scale, and we observed that there is a lot more manufacturing process which were consume a lot of time. So what we have done is we reduce that time for manufacturing process, not much time, but at least we try to reduce 40 to 45 minutes 40 to 45 minutes at one product for so objectives of our case study is the maximization of service level, minimization of lead time, improve cycle time, and improve performance of internal supply chain.
Further, I will explain the methodology. We have done a lot of research paper, literature survey, in which we have find that the minimization of the cost is not happening. Which is happening, hampering the internal supply chain also, due to increase in the total cycle time. So we use the AHP processes, which is the analytical hierarchy process, and the balance scorecard. The balance scorecard, in which there are four main aspects, which are mainly financial perspective, customer perspective, and internal perspective, learning and growth. In which we have taken the internal process perspective, in which we have applied the AHP process, which is the analytical hierarchy process. It is the method of organizing and analyzing the complex decision using the math and psychology. From this, we have calculated we have find with the various mathematical metrics that we should mainly focus on the total cycle time, and
So our calculation for the analytical hierarchy process.
From this, we have find that the total cycle time we should mainly focus on, and after that we have applied this on the case study in MSL Drive.
So what we were done after that, we visit SL a lot many times, and we found that there is a process called furnace tempering. So we can replace furnace tempering to induction tempering process. So we reduce the time for manufacturing a product which contain a lot time to manufacture, and we install this process on assembly line, so we can reduce the time of manufacturing process. So what is the furnace tempering process? So furnace tempering process consists that heating of a job with a batch wise production, and in induction tempering process we can heat that job with the on time on assembly process, so it is easy to reduce the time. So if we compare both furnace and induction tempering process, with the 250 batches, so we can see that furnace tempering consists of 2 hours. With the induction tempering process, it only take 10 seconds tempering time. Plus we also increase the job property or the material properties with the help of that. Also, if we compare with the per day production, we can see that we only consume 20 units. Here it is 80 units. And a lot more. So here is our conclusion. In minimization of cost is not having due to increasing total cycle time. So we performed internal supply chain is hampered. In project where we try to minimize the total cycle time so that performance of internal supply chain can be improved by changing the process or replacing. So our reference is for the thank you, ma'am.
Thank you so much, sir. Any questions from the respected judges?
Yeah, Rishikesh, is it applicable to a single product or a mix of products?
No, sir. We can actually apply it on whole assembly, or we can actually apply on assembly, directly on assembly. If we think about the furnace tempering process, so what we have to do is we have to wait till the the heating of batch is done. On and replacement, we can actually this process we can install it on assembly directly.
Yeah, no more questions from my side.
Thank you, sir.
Thank you, sir.
Shall we move to the next presenter, sir?
Hello. Ma'am, I suppose all the presentations are over now.
Yes, sir. But some of the students have not present there.
Okay,
So
so we
should
just
call
want to
their
give a
name?
reminder call.
Okay. Sunil Kumar, sir, a review on machining of polymer composite reinforced with natural fiber. Sunil Kumar, sir, am I audible to you?
So you can move ahead.
Yes, sir. Kunal. Kunal Sheghaukar, sir.
It is over, ma'am. The presentation is over.
Sorry, sir.
It is number 7, 8 pending now.
Yes, sir. Kapil
Saner and
sir.
Amit Ashok Shinde.
Yes, sir. Kapil, sir. Comprehensive review on recognizing the effect of extreme heat on poultry birds in tropical environment. Kapil, sir, am I audible to you? Sister Anastasia. Okay, sir. Amit Shinde, sir. Design and analysis.
Yes,
Yes,
ma'am.
sir.
Can I present now?
Yes, sir, you can.
Okay, just ma'am, my screen is visible.
Your screen is visible.
Okay. So, okay. Can I start now?
Yes, sir.
Yeah, okay. Good afternoon, everyone. My name is Amit Ashok Shinde. Currently, I am pursuing MTech from Rajaram Bapu College of Engineering, Islampur. The topic for the today's presentation is design and analysis of trailing arm of Bajaj Auto Rickshaw, and my guide name is Dr. S.S. Gavde, sir. So moving ahead, as we know, a trailing arm is a part of an automobile suspension. It is located in the front of the rear axle and it connects axle to the rickshaw chassis. The arm will move up and down when the rickshaw is driving on a bumpy road to make our ride smooth. A trailing arm suspension is an automobile suspension design in which one or more arms are connected between the axle and the chassis. Seen from the other side, the arm is roughly parallel to the ground with the angle changing based on the road irregularities. The trailing arm suspension system is commonly used because rear suspension in three-wheeler automotive vehicle rickshaws offers the benefits of getting little elements count and it has easy configuration. The trailing arm suspension system consists of two arms that are mounted to the chassis at one finish to the wheel up and the opposite finish with the bushing. The arm should be stiff enough to support the lateral forces while cornering the vehicle. Also, it will be versatile enough to permit the right hand and the left hand wheels should be balanced. Moving ahead, this is the abstract of my study. I will just brief in short. An auto rickshaw is three-wheeled vehicle with one steering wheel. These are the commonly used in developing countries as they are very cheap and has low maintenance cost and low operation cost also. This system is usually used in the rear suspension in three-wheelers and offers straightforward configuration. In this work, I have made the design of armor in SolidWorks and the analysis is carried out in ANSYS. So to find out the reasons of trailing arm failure, we have also met some of the local rickshaw drivers and get information from them. So we find out that the main three reasons for the failure of trailing arm is extreme heat. Due to its location, the trailing arms and its bushing is exposed to extreme temperature. High heat in particular, it can cause the rubber damping material of the bushing crack and hardens the material. Excessive twisting. Twisting also shortens the life of the bushing. If the bushing allows excessive roll on your vehicle, it may twist and eventually the bushing gets teared. And lastly, the fluid leaks also causes bushing to deteriorate and potentially fail. So the problem statement, the trailing arm has been subjected to forces in all directions because of the possibility of bending and torsional stresses. On most of the model, trailing arm failure leading to dangerous consequences. There are numerous reports of the arm of cracking and collapsing. If this should happens at highway speed, then driver could lose the control of the vehicle. So the entire analysis is done to reduce the trailing arm failure. So these are the main objectives of my study, to find out the failures of existing trailing arm system, to design an analysis of trailing arm, and to validate the experimental results of existing trailing arm with the software results. So for modeling, dimensions are required for calculating the boundary condition. Hence, the CAD model of the trailing arm is necessary. The conventional model used in auto rickshaw is taken. Dimensions are taken through reverse engineering through hand calculations. The CAD model is made by the commands in SolidWorks, and the measurements are taken with the vernier caliper, and the FEM analysis is carried out by using the ANSYS software. So this is the dimensions of trailing arm we find out by measuring with the vernier caliper. This is the CAD model we designed in SolidWorks. Moving ahead, analysis of trailing arm. The advantages of, at present, the trailing arm is made up of mild steel. The advantages of mild steel is it is best steel alloys and it has very strong. It has best stiffness overall and it is long lasting. Also, the steel is traditional material for the trailing arm and it is also in cheap rates. Steel perform both well in terms of both yield strength and ultimate strength, particularly if it is carefully alloyed and processed. These are the properties of the mild steel which we used for the manufacturing of steel, conventional trailing arm. Moving ahead, the loading and boundary conditions we selected for the analysis of the trailing arm. The gross weight of the three-wheeler distributes on each wheel, gross weight of the persons riding on the auto rickshaw. The full static load located at the centroid of the three-wheeler, hence each tire has a share triple the load of the full static load. The gross weight of the rickshaw is around 1000 kg. Assuming the weight of each passenger is 100 kg of each person and luggage weights 100 kg each hand. The total static load will be 1000 kg, assuming 500 kg per weight by which the data available. So each tire will share load approximately 333 kg when a car has an impact within the motion control arm objects with the longitudinally equals. So by calculating, we find out that the total force acting on the trailing arm is 3500 Newton. So the static analysis is carried out in ANSYS. For the 3500 Newton, we find out that the deformation is 0.25 mm and the von Mises stresses existed are the 251.41 Newton per mm square. Also, we find out the static analysis for the 2G gravity condition for 7,000. So hence for the 7,000 Newton load, we find out the deformation is 0.51 mm and the stresses are doubled 502.82 Newton per mm square. So these are the results we find out from the analysis of the work. To validate the analysis, we also done the experimental testing of the trailing arm on the universal testing machine. A universal testing machine is used to test the both tensile and compressive strength of the material. UTM are named as because they can perform different varieties of tests on different diversities of material components and structures. UTM can accommodate many kinds of materials ranging from hard samples such as metals, concrete, flexible samples such as rubbers and textiles. This diversity makes UTM equally applicable to any industry. The UTM is versatile and valuable piece of testing equipment. It can evaluate material properties such as tensile strength, elasticity, compression, yield strength, elastic and plastic deformation, bend and compression. It has different load capacities, some as low as 5 kilonewton, while others are having 200 kilonewtons. So these are the specifications of the universal testing machine, which we used for the testing of the trailing arm. It has capacity of 400 kilonewton. It has least count of 0.04 kilonewton, and the ram stroke is 200 mm, and the weight of the machine is approximately around 2,300 kg. So for the experimental procedure, the component is fitted on the UTM. After successfully mounting of the component, load is applied. Single force load is applied as per FEA analysis, and the reanalysis is performed to determine the deformation of the trailing arm. The deformation of the component is observed in 2 trials, which is discussed above in ANSYS. So we find out that the deformation on the UTM is similarly gave similar results of the deformation gives similar results as of the ANSYS results. So currently now we are working on the optimization of the trailing arm, like design modification or the material modification. Also there is a future scope in which composite materials can be tested as an for alternate materials. Nonlinear analysis also can be performed to find out more accurate results, and thermal analysis also can be done for the further study. These are some of the references I have used for my study purpose. Thank you. Thank you, sir. Any questions?
Thank you, sir. Any questions from the respected judges?
Hello, Mr. Amit.
Yes, sir.
Your topic is clearly mentioning the Bajaj auto rickshaw, isn't it? The trailing arm of Bajaj auto rickshaw.
Yeah, yes, sir.
Now, almost 90% plus of the auto rickshaw,
yeah,
they are having the Bajaj auto rickshaw only, isn't it?
Yes, sir.
So apart from the references, that is the research papers, you should have done a live survey also.
Yes.
So do you have that report as to what is the life of that trailing arm of the existing Bajaj vehicles? Is there any dissatisfaction level from the auto drivers?
Yeah, sir. We visited the local auto drivers. From them, we get that in any 3 to 4 years, they have to replace the arm bushing, or also they have, otherwise the arm will also get bent.
Yeah, but the bush replacement is quite a common phenomenon that is always recommended. No?
Yeah.
Then
also the bend. Sometimes if the due to excessive loading in the while driving on bumpy roads, sometimes the arm will also bend if the wake after.
Exactly. Now I was coming to the same, because this data and the research papers data, it might vary depending upon the road conditions and the environment in which they are operating.
Yes, sir.
So how can you comment referring to the research papers then?
Sir, we can calculate the load which acts on the trailing arm.
Yeah, it also varies. You know the conditions.
Yeah. Yes, sir. Yeah. So we specified this. We assumed this condition, sir. Like 4 persons sitting on the rickshaw, luggage weight, and the curb weight.
Yeah. But normally the failure occurs when there are 6 to 7 people occupying seats in the auto rickshaw.
Yeah, it is, sir. We assumed at a maximum level, sir.
Yeah. Okay. Is there anything you said composite materials? So you have some research papers wherein composite materials are recommended for trailing arms?
Yes, sir. I have seen some of the papers in which we can also use the composite materials. It will be more costly, but has less weight. So it will be beneficial.
Okay. Because whatever you do, the validation will be very important.
Yes, yes, sir.
Now this is a petrol operated auto rickshaw. Has it anything to do with the fuel? Like battery operated vehicles, they'll be facing some other issues.
Yeah.
But still the trailing arm issue is common?
Yes, sir.
Okay. Because batteries will be adding to the weight again.
It depends on the suspension, which suspension system that the rickshaw uses.
So in this presentation, you never mentioned about the suspension.
Sir, that's why the Bajaj automobile normally uses the trailing arm suspension system. So mostly the conventional ones are used on the trailing arm suspension system.
Okay. Okay, this is all from my side.
Yeah, thank you, sir.
So can we move to the next one?
Yes, ma'am.
Yeah, thank you, sir. I would like to invite Prashant Amle, sir, for presentation on experimental investigation of process parameter in turning using design of experiments. Prashant, sir, are you present there? Okay. Nirbhay Yadav, sir, on presentation of effect of working fluid and pipe material on performance of heat pipe. Okay. Shubham Rajesh, sir, on presentation of design and development of fatigue testing machine. Okay. Akash Gaikwad, sir, on presentation of hybrid electricity generation on highway. Okay. Sushil Nikhade, sir, design and fabrication of coin operated portable mask vending machine. Sushil, sir, are you present there? Sachin, sir, we are done with it.
Yes, ma'am.
Yes, sir.
So Kaustubh, sir, are you there in the meeting? Hello. Swapnil, sir. I'll just ask the coordinators to contact you.
Avinash, sir. Hello.
Hello.
Hello, Abhinash. Hello.
Yes, sir.
Abhinash will take decision. No? We'll just wait.
Okay.
Wait for a minute. Hello, Abhinash, are you there? Hello.
Jade sir.
Hello.
Jade sir, am I audible to you?
Yeah.
All presentation finished?
Yes.
Okay. I'll just check from session 2. Okay. Might be one or two presentation is still remaining in session 2. So after completion of all that sessions, we are just going for the validatory program.
Okay, fine.
Okay. So I request to all participants to wait for the validatory program.
Okay.
Okay, uncle. Okay. कोई बात. चार विकेट गए.
So we will start the validatory session within 5 to 10 minutes.
एक आणि दोन नाही आले का? नाही. एक दोन एक नंतर दोन तीन चार नाही.
Hello. Hello, sir.
Yes.
Sir, my name is not there, sir.
Hello.
No, sir, my name is there or not, sir? My name is Risha KS.
So have you presented your paper or not yet?
Presented, sir. Not yet presented, sir.
Not yet. In which track?
ECE, sir. Electronics and Communication.
ECE. But
Yes.
I think the track was yesterday itself. Na? We'll check just a minute. Just a minute.
So from IFERP, they were scheduled today, sir.
Just madam.
It is in breakout 2B room.
Yes, ma'am. I have gone there. Shall I join in 2B room, ma'am?
Yes, sir. Yes, sir. Please join in that.
Okay.
Hello, ma'am. Hello, ma'am.
Yes, ma'am.
Yeah, is this a 2B session? I mean, CS and IT?
No, ma'am.
So how can I join that?
Ma'am, breakout 2B.
Sorry?
Breakout 2B room.
I mean, I didn't get any link for that. So I just joined through this.
Just a moment, ma'am.
Yeah.
2 मिनट रुक जाते हैं उसको किसी से फोन भी नहीं। Thank you all for your valuable presentations. I welcome you all for the valedictory function. Announcing the best paper and best paper presentation from day 1, technical session A, 1A mechanical, best paper, investigate the impact of riser tube shape variation on flat solar water heater performance using CFD analysis, and design and development of earth analyzer. Best presentation for design optimization and thermal analysis of disc brake rotor of two-wheeler. Day 1 technical session from 1B CSE and IT. Best paper goes to far and few review in blockchain technology and its application. Best presentation goes to response of Brassica rapa to verify light intensities and type of nutrients solution grown under hydroponic system. Technical session 1C for ECE and EEE. Best paper goes to analysis of COVID-19 lung computed tomography scan image using segmentation and estimation of seasonal variation in module temperature model coefficient for heterojunction with intrinsic thin layer technology PV module. And best presentation goes to second generation Intel 8085 microprocessor and its data transfer instructions. Day 2 technical session for 2A mechanical goes to best paper goes to evaluating frontal crash test of developed vehicle chassis farm structure to identify crashworthiness through scaled model for injury reduction and design analysis and ampere weight optimization of left panel using composite material. And best presentation goes to an overview on anti-COVID coatings research recommendations. Technical session 2B for SE, SCE and IT and ECE and EEE. Best paper goes to development of medical device fit telemedicine application, and best presentation goes to novel odd even configuration for migrating the impact of partial shading on PV generations. Technical section 2C for civil and SNH. Best paper goes to the effect of TB doping on the structural and magnetic properties of ZNO nanoparticles, and best presentation goes to analysis and design of precast RCC box structure by pushing method as per IRC and IRS code in different traffic conditions. A heartiest congratulations to all the presenters and the paper. Thank you so much. Now I would like to welcome Dr. Anil Dubey sir to give the valedictory speech. Welcome you, sir.
Thank you. Okay, am I audible? Hello.
Yes, sir, you are audible.
Yes, sir, you are audible.
Okay, a very good afternoon to all. It's very pride moment for me that to be part of that valedictory function. As we are moving towards the concluding part of that conference, ICETET 2022. If you look back the activities that took place in last 2 days, there is a lot of knowledge sharing, as I said yesterday also. If you look at the list of list of the keynote speaker, really we learn a lot because they share their experience of 20 or 25 years within a 30 or 35 minutes with all of us. Since it is a multidisciplinary conference, so we learn a lot from other disciplines also. Just like I belong to mechanical, but I learn so many things from the ECE, electrical, as well as the civil and the electronic telecommunication branch. First of all, I congratulate all the participants and the best paper winners. Though the number of papers, all the papers, their qualities are much better compared to the when I'm comparing with the last year's conference. And it is very difficult even for the, I think that very difficult for session chair to select the best presenter and the best paper. As I said, that kind of event, when we talk about the conference, it's a platform for the learners because everybody learns something from that conference. Though he is a PhD scholar, though the doctorate people or the UG or PG students. And this is possible just because of the support from our management, support from IFERP, and also from all the participant and audience. When we talk about that, since we are on the concluding part of that event, when I look back and talk about this conference, so it was initiated in the month of January. And earlier we decided to go for the hybrid mode or for the physical mode, but because of certain limitations, Third time we conducted this in virtual mode. But here, with the support from all the participants and all the stakeholders of this conference, I can assure that next time we will be in position to conduct the physical mode of conference, and we'll do it shortly with the support from all of you. This conference, the success of that conference is entirely depend on the team which is working. So those are the backbone of that conference. Just like the team from IFERP, from day one, we are in touch with the Avinash. I would like to announce their names, like the Avinash Das and Sushmita ma'am. Along with them, my colleague, Professor Swapnil and Professor Kaustubh, they work very hard to make this to be successful. And also the participation team, participants, and the support from our management and support from the IFERP team, it is possible to conduct or to successfully conduct this conference. So I wish all the best to all the participants and hope that very soon we are in a position to meet physically in our campus, though the conference is over. But I request to all the participants that at any moment of time, be in touch with our institute, our department, or IFERP team. If you need any kind of support, or if we can do in collaboration with some other activities. So thank you, IFERP. Thanks to all the participants, and thanks to our management, especially our chairman, Dr. Sandeep Kumar Jha sir, that his motivation, because of his motivation only, it is possible to conduct consecutively the third time this conference. Also, I'm thankful to our academic facilitator, Professor Pramod Karole sir, and our beloved principal, Dr. D.P. Patil sir, along with my all colleagues and team IFERP. So thanks again to all. Thank you.
Thank you so much, sir. I would like to welcome Prashant Kulkarni, sir, Assistant Professor Mechanical from Sandeep Institute of Engineering and Management, for the vote of thanks.
Very good evening to you all. I, on behalf of Organizing Committee, SIM, Mechanical Engineering Department, and IFERP, express my deep sense of gratitude to our Honorable Chairman, Dr. Sandeep Kumar Jha, for his kind support, approval, and cooperation for this conference. I am also grateful to Honorable Professor Pramod Karole, our academic facilitator, for his guidance and kind cooperation. I am very much thankful to all the keynote speakers and session chairs for their valuable time and words of wisdom. I am really grateful to IFERP Rudra sir and his entire team for their support and cooperation for the conference. I am really grateful to our beloved principal, Dr. D.P. Patil sir, convener of the conference, for his continuous support and guidance for the conference. I am really also grateful to respected Dr. Anil Dubey sir, co-convener of the conference. He is really the man behind this conference. Successively 3 times he organized this conference. His efforts, support, and cooperation and encouragement helps this conference to be done. I also express my sincere thanks to Professor Swapnil, Professor Kaustubh, Avinash, Sushmita, Diya, and all the members of SIM, Organizing Committee, and IFERP. And lastly, I express my deep sense of gratitude to all the participants, without which the conference cannot be happen. Also, I am very much thankful to all the persons who are knowingly, unknowingly involved in the success of this conference, and successively 3 times we make it happen that the conference become successful. So 3 cheers for SIM, Mechanical Department, and IFERP. I hope this cooperation will long-lasting cooperation, and in future also, as respected Dubey sir state that in future also we are going to host the conference physically. So I hope in future also we will enjoy the support of IFERP and will do this type of conferences again. Thank you all. Over to you, Dia.
Thank you so much, sir. Thank you all to attend this conference. Thank you.
Thank you, sir and madams.
Thank you all. So we are winding up this conference here. Thank you, Dubey sir.
Okay. Thanks to all. So now we declare that the conference is over. Okay.
Yes, sir. Yes, sir.
And hope that very soon we are going to once again meet in physical.
Sure, sir.
Okay.
Sure.
Thank you. Thanks to all. Thanks. So now we can leave. You can leave them.